Development Area. Welcome you, sir. I once again request outside salt. Take the salt.
स्वभक्तानुकूलं जगद्देशमूलं निरस्ताशु समस्तहरेशं अवधेशं जगद्वैवशं
outside the salt. On the back rows, and please take your seat in the front row.
सुपरिष्ठं त्रिलोकी वरिष्ठं गुरूणागरिष्ठं स्वरूपैकनिष्ठं सदा महावीर.
I request all the nominated delegates of Northern Toll. All the nominated delegates have not come at time.
सुगीतं सुरक्षं परितं तेरगीतं
Good morning, distinguished guests, scholars, industry experts, delegates, nominated delegates from all the areas of Northern Limited, nominated delegates. I request all of you to take your seat as soon as possible. I request the front row. I once again request all the delegates to take the seats in the front rows.
सदा पुष्पहासं सन्निवासं शतादिभासं सत्तीतवस् सच्चात्
We are going to start by 9:30 a.m. I once again welcome you all to
श्रुतिव्रातसारं जलाकर विहार
6th International Conference on Technology and Sustainability, that is ICOMS 2023. We have 5 this session. The paper presented by Development of Maintenance Policy. Next one by Aditya.
सुनानी करे से तुझे
I request Santosh Kumar sir to please take the diet. The next paper will be on design and development of for excavator working Opencast. The paper will be presented by Kumar sir.
Jaya Vimuktir Vimanam Subhaktanukulam
Paper on design development is authored by our teacher, Dr. Mohammed Sadiq.
Samasta Paresham Bhavati Shasya Padesham
By
Venukatiham Surapadesham
Kumar sir and
Supashtam Triloki Varishtam Purunakarishtam Swarupai Kanishtam Sada Veeram Mahabodhiram Bhaje
session is mining. What is mining? I mean, mining. I once again request our last speaker, Piyush Singh sir, take the dais. We have with us distinguished personalities as chairman, co-chairman, and reporter of I request Deep sir from IIT. I request all of you to please put your hands together for the chairman. Have with us leader and mining engineer, Rajiv Kumar sir, area general manager, Madhya. We welcome you, sir. I request all of you to put hands once again for chairman. We have with us Sumant sir, area general manager. I request you, sir, on the dais, welcome stage of ICOMS. And we have a big round of applause for our chairman, co-chairman, author, section of 5 technical papers, giving valuable insights to cover it. What makes this exciting with one of our I request our chairman sir for the session is based on the theme.
Jaya शयान विमुक्तिर्विमानं स्वभक्तानुकूलं जगद्देशमूलं निरस्ताशु समस्तहरेषु अवधेषु जगद्देशं दक्षिणेशं सत्येकटेनं विमुक्ताखिलेहं सुखगेहं हरे सुपरिष्ठं त्रिलोके वरिष्ठं गुरूणां कनिष्ठं स्वरूपैकनिष्ठं सदा यो महावीरं महावीरं भजेऽहं सुगीतं सुरक्षं परितं वीरं भजे नारायण नारायण शरचन्द्रभालं भालं नभुतीलकायं दुरावारमायं सुपद्मासं भजे देहं सदा विवासं पुष्पहासं सन्निवासं शतालिवासं सत्तीर्थः सच्चा श्रुतिव्रासारं जलागर्विहारं चिदानन्दं मोक्षस्वरूपं धृतानेकं शयानं विमुक्ते स्वभक्तानुं जगद्देशं पुरं कष्टाशुभे
how the maintenance policy. That is one of the real time fault diagnosis. Real time fault diagnosis the normal system is not very good, but any starting that is normal condition. When we not take the symptoms, and after that it's converted into the fault zone. Then after it's converted into the failure zone, and after that it's converted into the breakdown, major breakdown. Our mukti which predicts the fault before occurrence of failure and take the uh, respective maintenance actions that can avoid the major failure of the heavy. So this one is the level one, level one representing the pre-failure condition, that is the sum of the causes occur. That condition we take in the sum of the preventive maintenance actions, and the system again come back into the normal. In the second, so that is the hidden failure level. That we also know is the symptom that machine giving the sum of the symptoms, and based upon the symptoms, we take the preventive maintenance section, and again must come back into the normal. Third one is the fault, and last failure, failure zone, and after that is converted into the breakdown. So our predict the fault based upon the any symptom observed in the machinery. There is a different conditions arise in the machinery. Decision under certainty, decision under uncertainty, decision under risk. Some decision under certainty, it means we know the exact root cause of the occurrence of failure. In that condition, we directly take the maintenance action without using in this type of model. Because we know exact about in the what is the reasons occur in the failure. But in the conditions of uncertainty and under the conditions of risk, we doesn't know about the exact cause why the machinery occur in the failure. That condition we need for the predictive model. That is the probabilistic model that given the probability of the corresponding root cause and which root cause is the most probable identify using the developed model by the Bayesian net. This one is a research gap in the present time. Most of the machinery research work is going on based upon the reliability, and based upon the reliability we make in the failure graph, and based upon that we take the maintenance action. Some of the research work going into the time box algorithm, the research are optimizing the server, maximize the productivity of the machinery, and in that way improve the reliability of the machinery. But previous research that are anyone research for giving the real time prediction of the failure. This one is the previous data, and that can predict the fault without the likelihood. One is the methodology that I have adopted, develop in the model. First, collecting the data, previous data plus real time data. Then after you after categorize the data and collected data can be converted to the valuable data. Then after we develop in the model by using the Bayesian network. Then after training and validation of the data, and diagnose the fault, and based upon the result of the fault diagnosis, it suggests the maintenance, and that can give in the real time solutions of the occurrence of fault. One is the objective of the first is to identify the fault. The fault is either in the degraded type or a catastrophic type, and after that identify the conflict analysis to detect to after that conflict analysis to identify the conflicting between the evidence and as well as validate the model, and after that the sensitivity analysis to identify the most critical parameter of the fault. This one is the reasoning how to categorize fault, that is the catastrophic fault and degraded fault. And this one is a case study from the we collected in the data from the Amlori mine. And this one is a developed model. This one is how to identify the threshold limit value like in the alpha, beta, and sigma that you to categorize the fault. And based upon the data and prior probability, likely, and posterior probability, after on that we categorize the fault either in the degraded type or catastrophic. One is the result and discussions. We consider it the different cases, but when the symptoms vibration and unwanted sound, that condition probable fault, and after that the conflict analysis, the conflict is negative. It means the identified evidence can support the fault, and second case when the symptoms that is a sensitivity analysis. There is three types of the variables. One of the targeted variable, that is another one is the evidence observed variable, and last one is the investigating variable that we are interested to identify. This one is the three different objective when we identify the one evidence, and after that we identify the another evidence. What is the objective of the Q is the rate value M1 and M2. M1 representing the difference between the F value, and M2 representing the maximum and minimum, the difference between maximum and minimum value. One is the we identify the threshold limit value of the alpha, beta, and sigma, that is the 0.5, 0.5, and which is the value which categorize the occurrence of fault either in the catastrophic and based upon the sensitivity value, we give it the one of the evidence in the model based upon the observed evidence in the real time. The model giving the exact solution what is the probability of the occurrence of the what as well as responsible respective occurrence of fault in we can use in this model that can decide either tagline can continue, operate or discontinue. And another one is the side in the required for the urgent or maintenance can be for the here maintenance time. One is the my publication. Are given. Is not to differ with answer that can send the data into the software and direct trigger the maintenance. The previous maintenance based upon the observation and dependent upon the time schedule. We first manufacturer recommend maintenance, the particular time interval. We start from the we symptoms when we observe any symptom, we directly feed into we collect the data from the some of the data from the log and some of the data from the sensor. That is the sum of the all in the drag line. Consider one of the part that is the drag system. That is the continuous. That is the real time. When we observe in the real time data, or when we observe any evidence into the drag line, that directly feed into the model, and based upon the evidence that provide into the probability of the occurrence of the responsible root cause, and as well as what is the probability of the occurrence of the fault. Just we call it this one is the one of the model that we develop in the network of that is called there. That is the screen. And then, any evidence, for example, in the operator identify the any abnormality in the drag line. Condition monitoring data plus operator that is the operator identify types of system from that is directly the model. Upon the data, the software directly the most the responsible for the model. No, just the information. Uh, Okay, here is the types of the maintenance generally we use. One of the time based and another one is the condition based. The time based that the time period is already decided based upon the time maintenance. This one is the condition based. When identify the abnormality that are occur in the major failure of the system, that's directly into the model and the on the model calculate the what is of occurrence on the root cause and what is the what kind of converted the system and based upon the probability that trigger the maintenance action and that directly inform maintenance they can ability. And normally, when we doesn't know about it, what is the exact root cause, is searching into the drag line. Where is the root cause occur? This page, the week. That is the time take. Okay, we discuss in after some. Model one collect the data from the drag sensor. That is the general sensor that already drags that like in the current feedback, stage feedback, temperature feedback. Thank you. Thank you so much.
Morning, all. Office, of the dais, officers, ladies and face digital transformation, digital in a field of mind. I'll be discussing about the implications of digital transformation. Mind. Why creative digital transformation is required in field of mind. I will take you to the genesis of digital transformation of mining. The government of India has set up a target million ton for itself, and that target achievement will come by addition of equipments by streamlining all the operations of the mining. As of now, our dependence on imports is almost 21% financially. Earlier it was 20%. The government, our years back, he has set a target of 4% by the right? So gradually we will be reducing our and Coal India has to produce more and more. Apart from that, commercial coal mining has also set its Indian coal mining sector large. As of now, is meeting its target and stuff, but they quite tougher for because has already come back of their auction. They have been given for private players, so the days will be difficult for coal. And as such, map was prepared by Ministry of, wherein certain steps were envisaged taken by digitalization is one of those steps, because digitalization in coal mining will act as an enabler for enhancing our streamline our mining by the resources and everything. For that purpose, digitalization 7 mines across India Limited. Yes, India is one of the has been for that 30 cases have been taken. What are the benefits of digital transfer? It is known for that it creates a lot of data and based on data, we can take the more product all the activities and decisions will improve and will be environmental impact. We can also anticipate quite reasonably time. Of aspects of wherein has been implemented 30 cases have been I'll be discussing another is survey based on technology, and the third patch augmentation at milling and plastic in northern British of the cost prices percent cost matrix. So any optimization in milling and plastic go a long way, saving our, I think, cost of. At the same time, optimization of drill and blast will no doubt go a long way in making operation efficient in terms of better maintenance, will also have environmental impact and optimization. Nowadays, the concept of this transformation, it is taking paradigm. I will now. I will be focusing my optimization is drilling and blasting, not drilling aspect, because one of the areas which was left untouched till now for the onset of this full program, where you all the latest technologies in the blasting, SME, where you all the latest access on electronic technology, where the drilling was one of the areas was even low priority. We have the set of like yes and on the tab type of there. Here was the area where the land was blasting. That is topography, capture the topography of that particular area, and then we put that traffic to the offices, and then we design them. Have our certain parameter burdens, subject, everything, and we design according to our set norm. That design again transported, mark the hoop, and drilling is done as per the design. Again, that topography is captured, and the holes actually drilled are matched with the designed hole. There is any picture. There is take corrective pictures after the blast. The next round of, but for this particular blast, change the time as per the design of the hole. Next slide. Of the line spot dragline free Opencast. We have kept burden as 9.5 meter to 10.5 meter. So actually, what we did there was a major variation in burden in spacing. So from the next round of blast, we have focused our concentration more on aspect of drilling burdens. This is one of the cases of digital transformation where we use based survey for drilling and blast. The front burden, the top burden, and the top burden. What we are doing in based on our experiences. But this phone technology has given us a tool deciding toe burden. What will be the toe burden? We can anticipate quite easily. We've given an not very expert in what will, and accordingly we design our parameters. The staggered charging pattern we have recently adopted for front room. The reading holes change the pattern of the charging that there is utilization. This is the analysis of fragmentation, and you can see that 80% of the particle size is less than 0.5 centimeters. For a dragline tip. And after implementation of this transfer optimization, we have increased our order factor 0.75. So there is a of 5 that in them. Now this survey it allows survey of access areas. We are not can take it has advanced analytics automatic stress detection, drainage analysis, and definition of actual mine development targeted mine at annual basis. Can prepare reclamation plan also, yes, plantation, stock volume, stock. I will by studying on all road analytics. We are doing Madhya. On videos, we can see, can here mark the areas which are for, the green part is showing the areas where all road width is, where gradient is also within limits as per statutory norm, as per the width of the units, and the red part of the area our body can all the energy, all our take care of area. After the studies, they found that almost almost 90% of the area is width is proper, gradient is proper. Very small area left untouched where we have red our our what are the limitations and benefits dependent as how is there scenario like their efficiency the generation white takes takes a like from time like for the as drive catch up. What we have done in our bus that we have installed certain sensors. Now we have installed 7 per 8 and plus 5 because the dashboard state plus and while map of the and of the mine management where our and dash. Next is a digital replication of our by pointing on any part of the can know all the details, temperatures, options, and everything can and accordingly can take correction for maintenance or in bid line or if line can take. We can see where the temperature is or vibration. Different parameters are checked. On the dash, you can see what is the tonnage per hour, size, where it's and where the problem is that we can identify it. Drilling and sir, we are now using 9-meter drilling in our HOE patches. The same sir, just 9-meter drilling HOE patches because typically that was one area where I results were not, but after time drilling, we have analyzed GPS and other instrumentation. What is the fragmentation? What depth of volume we are covering after each blasting? So that is giving a good result. We are analyzing in a proper way. Earlier, which was not there. It was just a visual. सर इससे ये फायदा है कि कोई क्या है कि पहले पता नहीं चल पाता था जल्दी से कि कहाँ पे है प्रॉब्लम, किस गियर बॉक्स में प्रॉब्लम है, किस रोलर में प्रॉब्लम है। बट अभी हमको पूरे सीएचपी के सर्किट में हमको ये पता चल जा रहा है कि हाँ इस पर्टिकुलर एरिया में, इस पर्टिकुलर सर्किट में यहाँ पे इस गियर बॉक्स में प्रॉब्लम है, यहाँ पे हमको तुरंत एक्शन लेने की जरूरत है पहले। तो इस तरह का हमारा जो डिसीजन मेकिंग है वो फास्ट हो गया है। हाँ बिल्कुल, हम यही यही कहना चाह रहे हैं सर कि अभी तो हमारा मैन पावर भी डे बाय डे रिड्यूस हो रहा है, हर जगह मैन पावर की क्राइसिस है, और ये आने से कम हमको ये पता है।
ये अच्छा टूल
एक मिनट सर, चेक।
गुड मॉर्निंग सर। संतोष, बहुत अच्छा प्रेजेंटेशन है, लेकिन मेरा एक क्वेश्चन है। मशीन कैपेसिटी के हिसाब से जब आप डिजिटाइजेशन में गए हैं, मशीन कैपेसिटी के हिसाब से फ्रेगमेंटेशन को एनालिसिस किए हैं?
सर अभी हम
10 क्यूबिक मीटर में फ्रेगमेंटेशन कितना होना चाहिए, किस साइज का होना चाहिए? जैसे फ्रेगमेंटेशन जो एनालिसिस हम करते हैं, एवरेज मीन ये निकालते हैं, तो उसके हिसाब से 10 क्यूबिक मीटर कैपेसिटी में कितना होना चाहिए, 20 क्यूबिक मीटर में कितना होना चाहिए, उसी से आपका इफिशियंसी जो है वो ऑप्टिमाइज होगा। इसमें आप कुछ काम किए हैं क्या?
सर ये आप बिल्कुल सही बोल रहे हैं सर। ये जो भी फ्रेगमेंटेशन एनालिसिस है, फ्रेगमेंटेशन तो बेसिकली इक्विपमेंट पे हमारा डिपेंड करता है। ये डिगिंग इक्विपमेंट है कि ड्रैगिंग इक्विपमेंट है, ड्रैगलाइन के लिए एक अलग पैरामीटर होगा। उसी तरह से डिगिंग इक्विपमेंट्स में भी 10 क्यूबिक मीटर साइज के लिए एक अलग फ्रेगमेंटेशन होगा, 20 के लिए अलग होगा। एचओई पैचेस में जहाँ पे हमारे स्मॉलर इक्विपमेंट्स काम कर रहे हैं वहाँ पे एक अलग फ्रेगमेंटेशन साइज होगा। इसके लिए अभी हम लोगों ने चूंकि अभी सितंबर में स्टडीज शुरू की है, तो अभी हम लोग का मेन फोकस रहा है अभी डिपार्टमेंटल पैचेस में ही, बट ग्रेजुअली अभी हम इसको और एनलार्ज कर रहे हैं अपनी
हाँ,
studies
क्योंकि
को।
मेन फ्रेगमेंटेशन ही से पे वो सारे चीज ऑप्टिमाइज हो। थैंक यू।
Here. 1 minute, he will give the
में जो फॉइन्स होते हैं, फॉइन्स का दो रोल, एक तो लुब्रिकेंट का काम करता है, दूसरा सीलर का। व्हाट परसेंटेज ऑफ फॉइन्स आर ऑप्टिमम दैट आउट
ये नॉर्मली हम लोग का जो वो रैमलर इक्वेशन है जिसके बेसिस पे ये फ्रैग ब्लास्ट सॉफ्टवेयर जो डिजाइन किया हुआ है उसमें हम लोग 80% साइज देखते हैं, इक्विपमेंट साइज के हिसाब से देखते हैं कि 80% जो पार्टिकल्स हैं वो पास हो जाने चाहिए डिपेंडिंग ऑन द साइज ऑफ द इक्विपमेंट, एक्सकेवेटिंग इक्विपमेंट। फाइन्स तो उसमें बाकी जो है वो फिर 80% में ही इंक्लूडेड है, लेकिन उस पर कोई पर्टिकुलर ऐसा कोई अभी सॉफ्टवेयर नहीं है कि बहुत ही जो फाइनर पार्टिकल्स हैं उसको अभी हम लोग इससे बहुत ज्यादा अभी रिलेट
आपका इस हर आधार है आपका ड्रिलिंग का पैरामीटर का पैरामीटर भी आपने कहा कि का पैरामीटर भी हम क्वांटिटेटिव पैरामीटर मॉनिटर करते हैं या क्वालिटेटिव पैरामीटर अच्छा है सब।
क्वालिटेटिव पैरामीटर इस सॉफ्टवेयर के थ्रू तो नहीं मेजर करते। बेसिकली मेरी जो स्टडी आज की थी वो ड्रिलिंग पैरामीटर्स पे ही बेस्ड थी। अब ये तो इतना वास्ट सब्जेक्ट है कि उसके लिए बहुत ज्यादा टाइम चाहिए अगर हम एक्सप्लोसिव पैरामीटर्स पे ही
ठीक है शर्मा साहब, वी कैन हैव डिस्कशन ड्यूरिंग ऑफ टाइम, लंच टाइम। समय की कमी को देखते हुए वी विल लाइक टू कॉल अनदर सेंटर, परमिशन फ्रॉम चेयरमैन सर।
Thank you. So we are having very lively discussion. That is very good. So the next presentation is production and productivity improvement. 26 meter cube deeper rope shovel paired with 186 ton truck. Will be presented by Mr. Piyushi.
The onset I would like to thank as and I especially thank children and the organizing. Bus and bus options and one of a kind district. We are here presenting from Papa. So Patsu Mining Corporation is part of a so kind of products in India and established and most use cases in shovels and that the idea of presenting this case is like what we have been highlight is very certain changes in putting like enhance the function and the very sustainable operation. The very first slide that we are trying to show here is safety. Safety is a good operation. Here, every Komatsu employees key points carry get. So, all to have a break of a second and just relook around you, the exits of this place. In case of emergencies, just be mindful of those places. Nearest exits. Starting on to the next part. So, typically, we all, being in the mining fraternity, we all know about the kind of thing tool that we have in the market. Front side of this slide, you would see the various categories of the loading that we have in the market, starting from mechanical wheel loaders, backhoe excavator, and excavator, shovels, and big shovels. What we are trying to highlight on the left hand side is you see the capital cost, productivity, and the machine life side. So how your capital from the lowest capital cost of the bottom and the top highest capital cost of a shovel, but same time delivered its productivity and machine. Similarly, on the right hand side of that,
chart, the arrow we are trying to show you from starting from the lowest operational cost at the top row being rope shovels and down to the highest operational stand cost per ton, and then these are the primary loading tools in the market. Till the introduction of the 42 cubic meters in the mining industry in India, primarily in the coal mining industry in India, PNS 2300s were with a 20 cubic meter bucket dipper were the only loading tools, the highest class of the loading tools available in mining operations. A brief history of this PNS 2300 XPC that we as of now started as a 2300 Mark machine way back in 1966. The bucket or a dipper capacity of 11.5 cubic. At PNH, what we do is usually we design the dippers in the whole number of yards, and on that it's up until there is a specific customer requirement. Size. And moving on to the 1981, the machine was designed to have a 20.56 cubic meter of a dipper. The machine named at XP. That's where we actually have 20 cubic meters incorporated in our standardized in the market. It had dual planetary and then it had air cooled converter cabinets for all. Then came 1984 and the machine was renamed as XPA and which had some modification to structural capabilities, and then drive systems as well as sealant. And then in 1993, PNS 23 XPB came where in the enhancement of the payload carrying capacity of the machine was done, which was from the 20 cubic meters to 20.5 machines. Then it also had a lot of structural and technological changes, which was based on the PNH 4100 class of machines, actually popular in the industry. In 2004, we came with a digital drive, complete digital drive Centurion system that was based on the SCADA system. We call it Centurion Supervisory Control System. Then it also was a small upgrade. The payload class was done, as
Mr. Piyush, please come to your topic.
Yeah. Moving on to the next slide, please. This is a brief history of the PNH. We all know we had 9 machines. In terms of the global references, there are 63 PS 2300 operating in the mines. We have supplied 189 machines. And the main topic that we are trying to speak on is like upgrading from the current 36 metric ton payload class of the 45. So we are trying to, on the right hand side, you will see a pie chart where we have shown the various category of various makes of 45 metric ton class rope shovels in the market. PNH again holds a section of having a large market share of 48. Slide. A small simulation has been done in this slide where we have tried to depict a simulation where we are using a 20 cubic meter bucket, dipper size, and putting onto a 190 or a 200 class truck. For consideration, we have taken Matsu 730E class trucks, which has got a payload 186, 183, 186 metric tons payload, and a small simulation has been done based on the considering average utilization of 72% and having of 10 years. That has been averaged out to give a standard operating hours of 5 hours per annum. With this, we would be able to load the dump truck with a 5 pass, and wherein you would see a volumetric utilization of 74%, but a payload utilization of 95%. This would, with this simulation, we have considered 7 hours of operation per shift, and then again you would be able to load a 14 number of trucks per hour, and an effective productivity of 1030 BCM per hour. So this would give you an estimated 10 years period 5.7 million BCM. Next slide. wherein when we upgraded to the 45 metric ton payload class, we would be able to install a 34 big yard or a 25, 26 big meter deeper on that, and considering a 95% factor. The similar combination of trucks, volumetric utilization, payload utilization would go up by go up at around 96%. It has been by 5%, and it would go up to 96%, and we would be able to load it by so effectively you are reducing one pass per cycle per truck, and this would deliver with this you would have a productivity rate of 1200 BCM per hour, which would make it around like 7 million BCM per hour. We have a very used case where customer is doing a production of 8.9 million BCM, utilizing very same machine per annum. They also do side loading this machine as well. Next slide. On the analysis that we have done with this upgradation, you would be able to achieve approximately 22% of increase in terms of productivity. Of course, there's a flip side of it that you will have to increase the number of trucks in the mines, but this also offers you a better flexibility. And in case you decide to enhance the number of trucks into the mines, you would be able to deliver same class of. So, not increasing the number of loading pools, but just by enhancing it, be able to for productivity for same product, and you are not altering your loading tool in that machine. Sustainability. I'll skip this slide and next slide. Komatsu is trying as a target of be carbon neutral. When we talk about the sustainability, rope shovel happens to be the most sustainable product in the market. We have done an analysis here on the chart. You would see we have done a CO2 emission analysis of a electric rope shovel versus a similar class of the hydraulic excavator and an electric hydraulic excavator. A bit of a surprise here with the current CO2 emission of the Indian grid that we consider, including the renewable energy sources. Electrical excavators happens to be the biggest emitter of CO2 emitter, even higher than the hydraulic diesel powered diesel powered hydraulic excavator. When it comes to the electric rope shovel, they're almost 55% lesser than the diesel excavator and 57% lesser than the electrical excavators in terms of carbon emission. And there is no direct carbon emission in the rope shovel. So this is one of the most sustainable product that the mining industry has. For the questions.
Okay. Question from the floor. Here. Front. Said that 12 of GM per hour. That is about runs for 3 hours per day. Did have obtained somewhere, or it's
no, so the numbers that we showed was more conservative. We showed around 7 million BCM per annum bank cubic meter, wherein operating hours. There are mines, the same class of machine. There are mines where they are running it same machine with around 6,500 hours per annum. So primarily, sir, 20 cubic meters, we are using it in whole India itself. Wherever we are selling or promoting 2300s, customer are they have based upon the category or the class of the they are going to customize. Bucket paper is customized.
Parameters of this payload how drive at position where we stand, where we create and what reload. Both are affecting at the cost of.
So very good question. So we have been telling this, I mean, multiple folks, we have telling this design department. At Coal India, what we do is we are used on the volumetric utilization from a as an OEM side, when you see the equipments are designed based on the payload capacity of the machine. So even if you talk about the
I am customer.
right,
I am talking.
right, so that's what I'm trying to. So once we decide, so you in our simulation you would see we have focused on payload utilization, wherein we are showing a payload utilization of 95 to 96%, whereas the volumetric utilization of the dumb body was around 74 to 75%. So volumetric utilization could differ based on the fragmentation of the material on that given day or that given period or over a period of time. But when we focus on the volumetric utilization, it is like your every single penny that you are putting in the machine is being utilized. That is so payload utilization should always be the primary goal where we intend to.
Your advice.
So mostly like say if the current tender context, you would see all the equipments that are from Coal India are mandatorily supposed to have the payload system. There are various at Komatsu we have a product called Argus payload system, which is like it is deployed onto approximately 200 machines globally. It is an independent system, very OEM or stick can be clubbed with various kind of makes and then like what it does is it offers a 3% plus minus variance guarantee for your payload.
Any other questions? I have.
Mr. Piyush, just would like to something from your side. You have just mentioned about equipments for sustainable development. So, Komatsu जो आपकी कंपनी है वो in this regard जो है क्या कर रही है based on hydrogen based इसमें अगर एक दो लाइन बता सके.
So there was a mining magazine as well. Komatsu has joined hands with General Motors, who are currently the largest hydrogen cell prominent, I can say, prominent hydrogen cell manufacturers. What we are doing is that the current use case deployment would be on the trucks of 60 ton. And the other thing that we are doing, so we have a proving ground. Battery, we are working on the battery side of it as well, but we are not very sure how far that battery thing would. The current use case basis is that we are using a twin system, sir, where we are using battery for the loading areas. Then when the truck is towards on the thing wood, it has a pen. It is powered through the electricity and that. On the loading side, sir, most of the equipment that we have are electrical equipments. Then we have a hybrid. It has one of that's it has got a big advantage of being such a machine that similar class of hydraulic excavator would consume approximately 50 liters of fuel per hour, whereas that loader consumes approximately 160 liters of.
I have just last question. What type of digitization?
It's absolutely digitized. It has got around 3,000 data points, which collects then 3 to 4,000 data points, which are integrated into the system. So effectively, this data in, garbage out kind of. So you get to see what is relevant to you. Within a second, more than 3,000 data points are captured in the machine. It has got a payload system. It has got a vibration system. It has got a operator monitoring system, and then it has got an automatic
Okay, Mr. Piyush, but my question remain unanswered. I just wanted to know कि practically आप इसको कहीं use कर रहे हैं कि नहीं? Hydrogen based equipment.
नहीं sir.
Just you have a partnership with the General Motors.
General Motors, sir, there is a GHG alliance because it was gas alliance. There are around 5 mining companies, top mining companies, with core development type का activity हो रहा है.
So it's still in development.
Still in development, sir.
Okay.
So you're
Thank you. के सिंह साहब कुछ पूछना चाह रहे हैं क्या? बहुत छोटा क्वेश्चन पूछिए और उतना ही छोटा आंसर एक्सपेक्ट कीजिए प्लीज.
यस सर. जस्ट ये मेरा टॉपिक नहीं है, बट चूंकि डिजिटलाइजेशन से इन्वॉल्व है इसलिए मुझे उसमें क्यूरियोसिटी है. आप वर्ल्ड लेवल के मैन्युफैक्चरर हैं और आप कैपेसिटी पर हमें किसी को कोई डाउट नहीं है. मेरा सबमिशन जितने डेटा पॉइंट्स से जितने डेटा आते हैं उसमें मेंटेनेंस से रिलेटेड जो डे टू डे यूज की जो डेटा है, क्या हम उसका डैशबोर्ड अपने मेंटेनेंस टीम को दे सकते हैं? मतलब ये कुमात्सु की तरफ से मैं ये जवाब एक्सपेक्ट
100%, sir.
आई होप हमारे टीम के लोग आपसे संपर्क करें, आप प्रोवाइड करिए, हमारे लिए बहुत बड़ा
ठीक है
होगा.
सर. I think he will answer you in the break.
Sir,
Thank you so much.
Thank you.
Thank you everybody.
Okay. Okay. Now the next presenter is Mr. Pradeep Kumar, and the paper is Design and Development of High Performance Wear Resistant Tooth Point Assembly for Excavator Working in Opencast Coal Mines of NCL. Mr. Kumar.
थैंक यू. गुड मॉर्निंग ऑल. आज का जो प्रेजेंटेशन है डिजाइन एंड डेवलपमेंट ऑफ वेयर रेजिस्टेंस पॉइंट असेंबली एक्सकवेटर्स वर्किंग इन ओपनकास्ट. ये जो पूरा प्रेजेंटेशन है मोस्टली एक R&D प्रोजेक्ट था हमारा, और इसकी जो सबसे सिग्निफिकेंस थी, पहले कि मैं प्रेजेंटेशन स्टार्ट करूं, हमारा जो पूरा कोल इंडिया जो सबसे बड़ा वर्ल्ड का कोल प्रोड्यूसर है, और जब हम बात करते हैं एनसीएल का जहाँ हाईली मैकेनाइज्ड माइंस हैं, तो हम लोग इक्विपमेंट हैं और हर साल मतलब थाउजेंड्स ऑफ करोड़ के हम लोग स्पेयर पार्ट्स या कंज्यूमेबल्स प्रेफर करते हैं. पूरी प्रेजेंटेशन या इस पूरा जो प्रोजेक्ट है या जिसको मैं प्रेजेंट कर रहा हूँ, इसका अप्रोच क्या था, कैसे हम लोगों ने विद इन टाइमलाइन इसको कंप्लीट किया, और ये एक ऐसा R&D प्रोजेक्ट था जो कंप्लीट होने से पहले हम लोग एक्सक्यूशन स्टेज पे आ गए हैं. मेरा स्पेशल रिक्वेस्ट रहेगा मोस्टली एक्सक्यूशन, इलेक्ट्रिकल, माइनिंग, लीगल और प्रोक्योरमेंट डिवीजन से काइंडली पॉइंट्स को परमिशन प्रेजेंटेशन स्टार्ट करते हैं. और इससे पूरा डेवलपमेंट था हमारे रिस्पेक्टेड सीएमडी सर का एक विजन था, जिसको हमने मटेरियलाइज किया हमारे सीएम एक्सक्यूशन सर श्री पातेंद्र और रामास्वामी सर, लीगल का टीम, सीएम सेंट्रल वर्कशॉप, और सबसे बड़ा जो कंट्रीब्यूशन था R&D टीम में श्रीजा सर, पीडी राठी सर, राजन मैक सर, और अभी जो करंटली टीम है हरी सर, नंदन, पूरा एक इंटरडिसिप्लिनरी टीम ने इसको टाइमलाइन कंप्लीट किया है. तो मैं डेवलपमेंट पे आता हूँ. केस इस तरह का है कि लास्ट ईयर का अगर हम डेटा देखें, लगभग 1340 करोड़ के हम लोगों ने स्पेयर पार्ट्स खरीदे हैं. और जब भी हम लोग स्पेयर पार्ट्स प्रोक्योरमेंट में जाते हैं, हमारे पास 2-3 इश्यूज आते हैं. सबसे पहले मेरा स्पेयर पार्ट क्वालिटी कितना अच्छा है उसका. दूसरा इशू आता है क्वालिटी बहुत अच्छा है, कॉस्ट कितना है. क्वालिटी ठीक है, कॉस्ट भी ठीक है, फील्ड में कैसा रहेगा. ये चीजें तब तक लोग इंश्योर नहीं कर पाएंगे जब तक हमारे इंजीनियर्स के पास में उस तरह के ना हो, हम क्रॉस चेक कर पाए. टेक्निकल स्पेसिफिकेशन बना रहे हैं, पर टेक्निकल स्पेसिफिकेशन को कितना टाइट करें कि की रिक्वायरमेंट एक टारगेट कॉस्ट रह सके. ये यहाँ से कुछ स्टार्ट का. दूसरा एस्पेक्ट ये था कि जब मैंने टेंडर भी अच्छे से कर दिया, स्पेसिफिकेशन भी अच्छे है, जो मटेरियल मेरे पास में आ रहा है वो कैसा है, क्या उसका डायमेंशनल एक्यूरेसी अच्छा है, उसका कंपोजिशन अच्छा है. पता लगा डायमेंशनल एक्यूरेसी भी अच्छा है, कंपोजिशन भी अच्छा है. जब फील्ड में जा रहा हूँ मैशिंग प्रॉपर नहीं हो रहा है, अलाइनमेंट में आ रहा है. तो डायमेंशनल एक्यूरेसी, ये चीजें चेक करने के लिए हम लोगों के पास क्या टूल कैसे हमने किया, ये एक एस्पेक्ट है. थर्ड जो सबसे बड़ा एस्पेक्ट है लीगल प्रोप्राइटरी आइटम, इंटेलेक्चुअल प्रॉपर्टी, हमारे लीगल एक लीड है. तो ये सारे एस्पेक्ट इस प्रेजेंटेशन में जो प्रेजेंट केस में जो हमारा डेवलपमेंट है, इंडिजिनसली डेवलप किए हम लोग, तो ड्रैगलाइन के बकेट का 2 पॉइंट और अडेप्टर था. तो इशू ये था कि एक तो फील्ड में परफॉर्मेंस, दूसरा प्रोक्योरमेंट का जो कॉस्ट है वो कितना होना चाहिए लोगों के लिए वाइबल हो. गवर्नमेंट पीएसयू में बहुत सारे गवर्नमेंट गाइडलाइंस हमें करना रहता है. तो इसके पीछे के साइंस से स्टार्ट करते हैं हम लोग। तो मोस्टली जो 2 पॉइंट अडेप्टर है जिस तरह का एक्सपेक्टर्स में हम लोग यूज करते हैं, या तो सिंगल सेट रहेगा 2 पॉइंट अडेप्टर एक बिल्कुल यूनिट की तरह काम करता है, या फिर उसमें क्या होता है दोनों अलग अलग पॉइंट अलग से, अडेप्टर अलग से, और लॉक करने के लिए उसके लिए एक लॉकिंग मैकेनिज्म रहता है। इसके पीछे का पर्पज ये होता है कि क्योंकि सबसे ज्यादा इम्पैक्ट क्लियर करता है माइंस में जब हम काम करते हैं, या तो इम्पैक्ट क्लियर होता है या अब्रेसिव क्लियर होता है। हमारा कुछ कहता है कि अडेप्टर का लाइफ अगर 800 या 1200 आवर्स है, तो 2 पॉइंट का मोस्टली 400 आवर्स के आसपास रहता है। तो एक अडेप्टर के साथ सेट ऑफ हम लोग यूज करते हैं। तो जब हम लोगों को स्टार्ट करना था कि कैसे डेवलप किया जाए, ऐसा परफॉर्मेंस अच्छी हो, इंडिजिनस हो, कोई लीगल इश्यूज ना हो, और हम लोग उसको डेवलप करें, तो हम लोगों ने जो माइंस में एग्जिस्टिंग कितने 2 पॉइंट अडेप्टर्स इस तरह के सॉल्यूशन या वेयर असेंबली हमने स्टडी किया। कुछ ऐसे 2 पॉइंट अडेप्टर थे जिनकी ज्योमेट्री बहुत सिंपल थी, नॉर्मल हम लोगों ने डायमेंशन स्टडी किया। कुछ ऐसे प्रोफाइल्स थे जिनको नॉर्मल हम लोग मेजरमेंट से नहीं स्टडी कर सकते थे, तो लोगों ने 3D स्कैनर यूज, और इसमें IIT BHU से हमें हेल्प मिला प्रोफेसर जैद खान सर, सर, और अकॉर्डिंगली हम लोगों ने से यहाँ पे एक सेट दिखा रहे हैं, ये एक अडेप्टर है। तो यहाँ पे आप वहां से स्लाइड नंबर 12 पे 12, थोड़ा बैक बस 12 पे। तो यहाँ पे आप देखेंगे एक साइड में आपका न्यूली प्रोक्योर्ड अडेप्टर है, उसी के बगल में जो रखा है वो वर्न आउट अडेप्टर है। यानी कि जब फील्ड में हम लोग यूज करते हैं विद इन 20 डेज 25 डेज सारा प्रोफाइल किस तरह का बनता है हमें। सेम न्यूली प्रोक्योर्ड पॉइंट को देखिए और वर्न आउट पॉइंट को देखिए, मतलब गियर के कारण इस तरह से मैट्रिक कट लगते हैं जैसे किसी ने वर्कशॉप में काटा हो सब। नेक्स्ट नेक्स्ट नेक्स्ट। हाँ, तो ये पूरा हमारा अप्रोच था कि किस तरह से डेवलप करें। तो सबसे पहला ये था कि एग्जिस्टिंग जितने 2 पॉइंट अडेप्टर हैं उनको स्टडी करें, उनका मेटलर्जी स्टडी करें, और उनके जो प्रोफाइल है वो स्टडी करें। नेक्स्ट था उसका कंपोजिशन क्या रखें अलग अलग, और उसके बाद में उसको मैन्युफैक्चरिंग पे जाएंगे तो क्या कास्टिंग करें, फोर्जिंग करें, सारा डेवलप। नेक्स्ट नेक्स्ट। हाँ, तो ये हम लोगों ने किस तरह से उसको 3D स्कैनर से स्कैन किया, स्कैन करके जो हमारे पास कैड फाइल्स आया। नेक्स्ट। यस, वीडियो प्ले कीजिए। ये अडेप्टर है जिसको हम लोग 3D स्कैनर से स्कैन कर रहे हैं, और साइमल्टेनियसली हमें इसका कैड फाइल जनरेट हो रहा है। नेक्स्ट नेक्स्ट। हाँ, जैसे ही मैंने स्कैन कर लिया तो हुआ क्या कि बहुत सारे 2 पॉइंट अडेप्टर्स अलग अलग मेक के थे, सबकी मैंने ड्राइंग्स देखा, स्टडी किया। और जो 3D स्कैनर का इनपुट होता है उसमें प्रॉब्लम क्या आता है कि आपने क्योंकि स्कैनर यूज किया है तो हो सकता है प्रोफाइल हम लोग स्कैन ना कर पाए। कुछ पार्ट ऐसा हो सकता है कि जो डिफेक्ट हो उसको भी हम लोग इंटरप्रेट कर लें अपने डिजाइन में, या कई बार ऐसा होता है कि कोई प्रोफाइल है या फीचर है जो हम लोगों ने मिस कर दिया, तो इसको क्रॉस चेक करना रहता है। नेक्स्ट। तो उसको क्रॉस चेक करने के लिए हमने क्या किया कि जो भी हमारा डेवलपमेंट था वो 1:5 स्केल पे डाउन कर लिया, और उसको 3D प्रिंटर में लगा करके हम लोगों ने STL फाइल था का नेक्स्ट जो डेवलपमेंट किया, तो ये इस तरह से आया। तो इसमें हमने डायमेंशनल एक्यूरेसी देखा, कोई डिफेक्ट फ्री डिजाइन है ये हमने इंश्योर किया, और देखा कि सारे फीचर्स प्रोफाइल जो उसमें थे वो क्या इसमें सब कवर हो रहे हैं, तो हम लोगों ने इसको देख लिया। अब इस चीज को जब फील्ड में लेकर के आएंगे तो कैसे इम्प्रूवमेंट करें, तो उसके लिए ये जरूरी था कि फील्ड में जब हम लोग ऑपरेशंस करते हैं, कटिंग या मटेरियल को लूज करने के बाद में मटेरियल एक्सक्यूशन का काम होता है। हाँ, तो ये पार्ट रहता है कि मेरा जो टूथ पॉइंट होता है वो 2 काम करता है, पहला है पेनिट्रेट करना, दूसरा फ्रैक्चर डाल के मटेरियल को लूज करना। और इसी चीज में हमें ध्यान में रखते हुए डिजाइन करना है। दूसरा ये ध्यान रखना है कि जो मेरा मैन्युफैक्चरिंग एस्पेक्ट है, कोई मैं ऐसा डिजाइन ना बना दूं मैन्युफैक्चरर के लिए बनाना टफ हो जाए या कॉस्ट बहुत बढ़ जाए, या कंपोजिशन कुछ ऐसा रख दिया कि कॉस्ट बढ़ गया, या कंपोजिशन ऐसा रख दिया कि वो फील्ड में परफॉर्म ही नहीं कर पा रहा है। तो ये सब चीजें मुझे ध्यान रखना था कि कॉस्ट क्या है, क्या है। नेक्स्ट कीजिए। तो हम लोगों ने सबसे पहले एग्जिस्टिंग का कंपोजिशन देखा कि किस तरह के कंपोजिशंस हैं, नेक्स्ट, फिर उसके मैकेनिकल टेस्ट किए और हमें ये पता लगा कि 2-3 एलिमेंट्स हैं जो सबसे ज्यादा इंपॉर्टेंट है। अब्रेसिव वियर रेजिस्टेंस बढ़ाने के लिए हमें मैग्नीज यूज करना पड़ेगा, इम्पैक्ट स्ट्रेंथ के लिए हमें निकल या कोबाल्ट यूज करना पड़ेगा, पर क्योंकि निकल ज्यादा कंटेंट रखने से थोड़ा महंगा भी होता है तो मोलिबेडनम पे हम ये, और अकॉर्डिंगली ये हुआ कि जो हमारा टूथ पॉइंट अडेप्टर होगा तो हम AI SI410 पे रखेंगे, और जो लॉक करने के लिए जो पिन रहता है उसको हार्डॉक स्केल पे जाएंगे 500 या 600। नेक्स्ट नेक्स्ट नेक्स्ट, हाँ रुक जाइए। लॉकिंग मैकेनिज्म जो सबसे ज्यादा यूज होते हैं जैसे ट्विस्ट लॉक है, स्क्वायर बार मैकेनिज्म है, बर्नेट मैकेनिज्म है, तो हमारा इंटरनल जो हम लोगों ने स्टडी किया था जिसमें नितुल सर का काफी योगदान रहा, तो ये था कि हम लोग सिंपल बनाए ऐसा कि फील्ड में तुरंत लॉक करना इजी हो, अनलॉक करना इजी हो। हमने सिंपल पिन एंड जो खोलर का मैकेनिज्म है वो अडॉप्ट किया और फाइनल डेवलपमेंट है। ये अलग अलग केस स्टडीज थे जो हमने देखे कि कैसे स्टडी कर रहे हैं। यहाँ रुक जाइए, पीछे वाली साइड में 40 पे 40 बैक साइड, इससे आगे आगे, हाँ यहाँ रुक जाइए। तो इसमें आप देख सकते हैं कि जो मटेरियल लूज करने का जो पूरा पैटर्न है वो इस पे दिखाया है। स्लाइड आगे, हाँ यहाँ पे देखिएगा सबसे पहले जो वियर है वो इम्पैक्ट के कारण है, फिर आपका 2 बॉडी है, 3 बॉडी है और लास्ट में फीडिंग वियर है। ठीक है, ये रुक जाइए। अब जो 24 क्यूबिक मीटर का जो ड्रैग लाइन है उसमें सबसे पहले मुझे ये देखना था कि मेरा जो टूथ पॉइंट अडेप्टर का असेंबली बनेगा उसका लेंथ कितना रखूं। अगर लेंथ में ज्यादा रखता हूं तो बेंडिंग मोमेंट बढ़ जाएगा, लेंथ कम रखूंगा तो मटेरियल को पेनिट्रेट ढंग से नहीं करेगा, मटेरियल लूज नहीं हो पाएगा, और अकॉर्डिंगली जो बकेट फिलिंग का है उस पर काफी इम्पैक्ट पड़ेगा। सबसे पहले हमने लेंथ को ऑप्टिमाइज किया, उसके बाद का था प्रोफाइल। नेक्स्ट, हाँ यहाँ पे देखिए थोड़ा और नेक्स्ट, हाँ ये हम लोगों ने देखा कि टूथ पॉइंट के अंदर ऐसे कौन कौन से वीक पॉइंट्स हैं जहाँ वियर सबसे ज्यादा होता है, जहाँ रीइंफोर्समेंट चाहिए, पॉइंट को हम लोगों ने ढंग से स्टडी किया फाइनल रिजल्ट्स पे। ये हमारा फाइनल डिजाइन था जो एनसीएल का पहला इन हाउस डेवलपमेंट और पेटेंट है, और जो कंप्लीट होने से पहले हम लोग इसको एग्जीक्यूट कर रहे हैं और विद इन जो हमें टाइमलाइन दिया गया था उसी में। नेक्स्ट नेक्स्ट कंक्लूड से का, तो कंक्लूजन मोटा पॉइंट इसमें ये है कि जब भी हम लोग स्पेयर पार्ट्स की प्रोक्योरमेंट पे जाते हैं तो डिजाइन स्पेसिफिकेशन के साथ में जो सबसे बड़ा हमारे पास चैलेंज आता है कि कॉस्ट कितना है, प्रोप्राइटरी आइटम इशू ना हो, कोई लीगल और केसेस ना बने। तो पहला ये था कि whenever needed or in case of critical applications, the technical specifications in term of material composition, design, surface property need to be defined properly in a scientific manner. दूसरा था कि during inspection of procured spares, we should use optical emission spectrometer, hardness tester, CMM और 3D scanner। सबसे पहले जो प्रोक्योर करके इंस्पेक्शन के लिए आया, विजुअल इंस्पेक्शन में जो भी है कि डायमेंशनल एक्यूरेसी चेक कर ले, तो उसके लिए या तो कोऑर्डिनेट मेजरिंग मशीन हो या 3D स्कैनर हो तो चेक हो गया। अब बनाने वाले ने प्रोफाइल बिल्कुल ढंग से दिया, अब कंपोजिशन क्या डालना है तो ऑप्टिकल एमिशन स्पेक्ट्रोमीटर से चेक हो गया। कंपोजिशन भी ठीक है, ड्राइंग भी ठीक है, पता लगा कि हीट ट्रीटमेंट ढंग से नहीं किया, सरफेस प्रॉपर्टीज उस जो हम लोग ओईएम ओपीएम को देखते हैं उसके बराबर की है या नहीं, तो उसके लिए हम लोगों को जैसे हार्डनेस टेस्टर वगैरह यूज करके हम लोग वो कर सकते हैं। और थर्ड पार्ट था whenever there is claim of proprietary item or IP issues along with quoting of exceptionally high price of spares, we need to explore for developing in-house solution through interdisciplinary team and collaborate. Next, ये थोड़ा सा दिखाने के लिए कि ऑप्टिकल एमिशन स्पेक्ट्रोमीटर क्या होता है, कैसे काम करते हैं, तो ये हमारे R&D का ही पार्ट था, हमारा प्रोक्योरमेंट इसमें चल रहा है। नेक्स्ट,
Very good presentation. Any questions from the floor?
एक्चुअली मेरा इसमें दो क्वेश्चन कि आपने मटेरियल को जब हम लोग फील्ड में ये चीजें यूज करते हैं तो फैक्टर्स पहला है कि जो आपका जो डाटा है एच पी का जो स्ट्रक्चर है लैंड मास क्या है, प्लास्टिक की क्वालिटी है, हमने ये किया है कि कास्टिंग की क्वालिटी अच्छी नहीं है तो सेम लाइफ लेस देन टाइम्स वारंटी लाइफ कास्टिंग ज़्यादा लाइफ वो फैक्टर है आपका। और कभी कभी हम देखते हैं कि थोड़ा सा लैंड मास भी चेंज, कभी रॉकी स्ट्रक्चर ज़्यादा रहता है, और कम स्ट्रेंथ का रहता है, सैंडस्टोन स्ट्रक्चर ज़्यादा रहता है।
सर इसका आंसर बिल्कुल ये है कि जब हम डिजाइन एस्पेक्ट स्टडी करते हैं सबसे पहले आंख मतलब विजन में यही रहता है कि मेरा स्टार्टअप प्रॉपर्टी क्या है। इसी के हिसाब से मैं टूथ प्रोफाइल को इसमें सिलेक्ट किया था। मैं सिंगल कर्व रखूं, ट्विन कर्व रखूं या फ्लैट कर्व रखूं। फ्लैट कर्व में भी 3 टाइप का होता है, डिजल टाइप का रखूं, स्टैंडर्ड रखूं, फ्लैट वर्जन रखूं। हमारा जो स्टार्टा है वो सूटेबल है कि हमें ऐसा चाहिए जिसपे इम्पैक्ट स्ट्रेंथ अच्छा हो, अब्रेसिव गियर रेजिस्टेंस अच्छा हो। इसीलिए हमने जो ओवरऑल जो प्रोफाइल रखा है बिल्कुल फ्लैट टूथ प्रोफाइल रखा है सर। तो ये पॉइंट हम लोग सबसे पहले डिजाइन एस्पेक्ट में स्टडी किया है। दूसरा एस्पेक्ट ये है सर कि जो ब्लास्टिंग किस तरह का है, फ्रेगमेंटेशन किस तरह का है, वो क्योंकि एक माइन किस तरह से मेथड्स है और किस तरह से काम करे उस पर हमारा एस्पेक्ट ये है कि मैं 2 पॉइंट अडेप्टर इस तरह से डिजाइन करूं, इस तरह से मैन्युफैक्चर करूं कि अल्टीमेटली जब मैं फील्ड में यूज कर रहा हूं तो मैक्सिमम जो रिजल्ट दे सकते हैं उतना वो रहेगा। तो ये फैक्टर हम लोग डिजाइन एस्पेक्ट में स्टडी किए हैं सर। तो आप बोल रहे हैं मतलब स्टार्ट ही हम वहां से किए हैं सर।
नहीं, मतलब मेरा एक था कि अगर इसके अगर आप एक कास्टिंग का स्टैंडर्डाइजेशन टेलिंग में
सर
ये स्टैंडर्ड रहेगा
सर
ये हिसाब से
क्योंकि हमारा जो ऑब्जेक्टिव था मैं समझ गया सर आपका रहा हूँ। तो ऑब्जेक्टिव सिर्फ ये था कि जो हमें डेवलप करना है उस पर फोकस करना है। वो एस्पेक्ट्स अलग से हैं, आपके ऑपरेशन का एक पार्ट है। ऐसे बहुत सारे मान लीजिए पैरामीटर्स हैं जो इसका पार्ट नहीं होगा। मेरा पार्ट ये था कि जो फील्ड कंडीशंस है उसके हिसाब से मैं ऐसा चीज डिजाइन करूं जो मेरे ऑब्जेक्टिव को फुल लोगों ने किया है सर। दूसरा सर एक रिक्वेस्ट था कि इस पूरी डेवलपमेंट को सिर्फ टूथ पॉइंट अडेप्टर के हिसाब से ना देखा जाए, ये इन जनरल कंज्यूमेबल्स के लिए या स्पेयर पार्ट्स प्रोक्योरमेंट के लिए है। मैं जो फिगर बोला था कि लास्ट ईयर का 1340 करोड़, अब जब फुल इंडिया की बात करेंगे हो सकता है वो थाउजेंड्स ऑफ करोड़ में जाए। हर जगह जो हमारी अप्रोच है ना सर, तो जैसे चाइना रिवर्स इंजीनियरिंग पे गया तो हम मैं रिवर्स इंजीनियरिंग यहाँ पे वर्ड यूज नहीं कर रहे हैं हम लोग, बोल रहे डेवलपमेंट का। पर डेवलपमेंट ऐसा कि मेरा फील्ड में वो काम करे। पता लगा मैंने ऐसा डिजाइन कर दिया कि बकेट की लिप पे ही फिट नहीं हो रहा है। वो सब चीजें हम लोगों ने ध्यान में रखी है। और इसको मैं शुरू में इसलिए बोला था कि इलेक्ट्रिकल, मैकेनिकल, इंडस्ट्रियल इंजीनियर सबके लिए इंपॉर्टेंट है कि जो आया एक्सेप्ट कर लिया नहीं। अब इंडियन एमएसएमई को हम प्रमोट कर रहे हैं, मेक इन इंडिया को, तो ये हमारे लिए जरूरी है कि क्वालिटी है तो हम सामने वालों को बताए कि क्वालिटी कैसे आएगा। सिंपली डिनाई करने से या सिंपली ये बोलने से कि प्राइस बहुत है ये वो नहीं, हमें इसका सॉल्यूशन डेवलप करने का ये केस स्टडी है। ये उसका एक प्रैक्टिकल एग्जांपल है कि विद इन टाइम फ्रेम हम लोग जो डिजायर रिजल्ट्स हैं वो कैसे डिलीवर कर सकते हैं। इंजीनियर्स को टूल्स देने पड़ेंगे, कोलैबोरेशन में जाना पड़ेगा, एक ऑनेस्ट अप्रोच रखनी पड़ेगी। और जो प्राइम मिनिस्टर का विकसित भारत का 2047 का जो विजन है तभी सच होगा जब सारे युवा, सारे इंजीनियर्स उस मकसद से आगे बढ़े सर। ये उस लाइन में है सर।
So, Mr. Pradeep, you have evolved some specifications based on our requirements. Is it correct?
Yes, sir.
Okay. And have you placed any order based on our specifications?
We are going to place order and we are expecting that by 15th of January we will test it in field, sir. Or any question?
Any other questions from the floor? Okay, thank you.
सर मैं थैंक यू बोलूँ उससे पहले एक रिक्वेस्ट था कि इस तरह से हमारे माइनर्स हैं पूरे देश की जो इकोनॉमी की जब हम बात करते हैं, इनोवेशन का रोल है कि बड़े जो हैवी इंडस्ट्रीज हैं, भले वो पीएसयू हैं या प्राइवेट हैं, देश की इकोनॉमी को एक तरह से सस्टेन किए हुए हैं। पर असली जो हमें लीड मिलेगा ना वो इनोवेशंस और इंटरप्रेन्योरशिप से मिलेगा। और आज क्योंकि 23 दिसंबर है तो आईकॉम्स के साथ में आज किसान दिवस भी है। तो इस देश की जो सही रीड है वो हमारे किसान, मजदूर और माइनर्स हैं। इसलिए इस चीज पे हमें फोकस करना है। जब हम कॉलेज में थे तो विजन 2020 था, विजन 2047 है। जब तक हम लोग उस चीज को मटेरियलाइज करने में नहीं लगेंगे नहीं हो पाएगा। ये जय जवान, जय किसान, जय विज्ञान, जय हिंद।
Thank you. Our next paper will be presented in online. Now he has already come online. He is Mr. Amit Bandari. The paper title is The Role in Change Management in Driving the Adoption and Implementation of Digital Systems in the Mining Cycle. Focus on drill and blast. So Mr. Bandari. So you have about 10 minutes to complete the paper. Oh, You are Mr. Hilton.
Hello.
And thank you. Thank you for the
Go ahead.
opportunity to talk to you today about change management in the mining industry. My name is Hilton Goldfinch, and I am a mining engineer with 30 years experience, not only in Australia, but globally and in many jurisdictions on our globe. So I would like to say thank you for this opportunity, and I look forward to having discussions and answering questions after this presentation today. So let's share the screen and let's move on. So Mine Excellence is a company that has exposure in currently 10 countries, and we are doing open pit as well as underground work. And as in all things, there's our disclaimer for you to observe. So with any presentation, we like to have a learning outcome so that people can walk away not only from Mine Excellence, but from today with a learning, an outcome, so that you have an understanding in this case.
Hello, Mr.
With
Hilton.
a focus on drilling.
Hello. Are you?
Yes.
Are you running the video or you are online present?
This is running a video for security of IT connection because I am currently in Australia.
Oh, okay.
So I do have the video running. However, if you would like for us to expedite this,
Yes.
I can share the screen and run through this now.
Yeah, we want it to be completed within 10 minutes, if you can.
Okay, very good.
Okay.
So what we will do, we'll expedite this and we'll make this very brief.
Yeah, thank you.
As you can see,
yeah, please go ahead.
Let's ensure that we have the visibility of the PowerPoint. Can we all see the PowerPoint?
Yeah, we are able to see.
Very good.
Go ahead.
Well, looking at the innovation and the changing global technology skills in and about the world, not only in India, but throughout the mining industry, and listening to the previous speakers, it is a consistently evolving field, and for us to change, we must be looking at logical, sequential systems to deliver the change, because so many places have failed in delivering change without having the supporting systems in place, whether that be understanding the experience required, having the willingness and the support of the industry leaders and leaderships, and not putting these measures in place. Otherwise, it is proven that the technical difficulties will not allow any change to be effectively implemented. So, in short, we're looking at the challenges of communication, the training, and the stakeholders understanding what needs to be implemented to adapt, adopt, and have that change sustained within the culture of the organisation. So not only is it investment, discipline, and the technology to ensure productivity, but also it assists in our compliance with all the varying KPIs that are set on us either by the legislative requirements by our governance, our owners, and the community. So to look at why do we need change management, and that is to have our people, to have the people that implement and use this in that comfort, in that security zone as soon as possible and probable, because we see so many resistance to change. How often have you, as leaders, as well as I have in my 30 years, come across people that say, I don't need to change, we've been doing this for years. However, if we do not change, we will be left behind, and that is not appropriate for the business, the economy, the environment, or the governance where we stand. However, when we see it is implemented and executed appropriately, we can have the probability of meeting our objectives significantly increased. Very quickly, an old saying of proper preparation prevents poor performance becomes very true. And without your support as leaders, and without your support to be able to communicate effectively through the workforce, both upstream and downstream of the targeted point of improvement, you will not succeed. So the phases really are preparation for the change, plan for the change, implement the change, and reinforce it so that once we have instituted or implemented that change, it is embedded into the culture and it becomes a normal part of the everyday work. So change needs specific training, specific people with skills to be able to deliver. And if we do not have this support, again, you will not get the success of the project. It is a collaborative effort so that in the change management, we look upstream and downstream to see where the constraints and the restraints are and quantify the value that we have delivered. This is where transparency of performance, utilisation, and what we are doing. Some people say that monitoring 3,000 data points per second is Big Brother, but we are here to make our work easier. We are here to observe where the challenges are, and that information is value, it is knowledge, and it helps us, the leaders, make the correct decisions for the longevity of the business. In drill and blast, I heard earlier, one of our speakers talked about fill factor, utilisation. This is a downstream effect of optimising drilling and blasting and implementing the technology and using it to its fullest extent, because the fragmentation, to have it optimised with the bucket size and the tray size of the truck, understanding what the throat of the ROM feeders are and the hoppers, that's where we can maximise the use of our energy, because energy is something that costs us dearly, and wasted energy is wasted money. This forms part of an overall integrated management system where we must not be siloed or be isolated and talk to each other. Yes, use technology, but let's not eliminate positive communication to be able to demonstrate our alignment, demonstrate the organisation, measure, check, and be able to improve every step. A 1% improvement in any process is an improvement, and it is cyclical. And as we embed this behaviour of change management, those 1%ers are cumulative. So to keep this concise, we are looking at the new roles that will be created with the digitisation, the ownership, the collaborative effort, and to have reasonable expectations, because a panacea or a one item that fixes all ills, fixes all problems, is not yet available for the industry. So let's look at how we can implement strong changes with the appropriate leadership and have the correct phased approach of digitisation, automation, to allow predictability, because predictability enables us to have a more concise estimation of our future, estimation of production, estimation of cost, estimation of longevity and utilisation of the equipment, and maximising the resource. It is cyclic, strong process, quality assurance, quality control. However, it takes education in this system, so that when we analyse, when we communicate, we can say, have we delivered the safest and most effective outcome? So as the industry changes, as we look at optimising every task, as we upgrade each other, upgrade the skills, we will be looking at change management to be embedded in every process, every project that we have. So with Mine Excellence, understanding that each project is different, understanding that the scope is clearly defined, we would like for you to seek out us as professionals so that we can assist in having fit for purpose change management procedures for you, because there is not one template that fits all challenges. So in this abbreviated presentation, I would like to say that Mine Excellence has international capability. We have an understanding of multiple commodities. We have the ability and the availability of skilled people, ranging from PhDs in many aspects of technology, and we look forward to answering your questions both here in this forum and outside at the booths that are currently available. Thank you.
Thank you very much to complete this on time. If any questions from the floor, it can be directly. Okay. So there is one question, Mr. Hilton.
Thank you very much, Mr. Hilton. A very pertinent and very persuasive subject. As I think, on any management, communication plays a very vital at top of all the. What is your idea about?
I agree with your comment of communication is vital, and we must always be cognizant of the audience. Not everyone will understand the language of high business. However, we must have fit for purpose people that speak the language of the users of these changes, whether it be an operator of an MMU or a mobile manufacturing unit that dispenses the bulk explosive down the hole, or the driller that has to put the drill in the right position every time on the bench, or the maintenance people that maintain our equipment. We are all aligned, and we must have the capacity and the facilities to communicate effectively. I heard a term earlier of rubbish in, rubbish out. What is valuable information must be filtered by the team leaders and be able to give the good news, which we celebrate, and the bad news that we also communicate effectively and immediately. Because if we do not communicate the bad news, we cannot control it, monitor it, measure it, and rectify that problem. So to answer the communication challenge, it is the right information in the timely fashion to the right people that have the authority, the level of authority to make corrective actions. And this can be done real time, or it can be done in formal, scheduled, planned meetings that have a dedicated agenda, because we do not want to waste time. We want to speak to the issue, rectify the issue, so that we can learn and progress and prevent any unwanted, unplanned incident, accident, or downtime in the future. Thank you.
Mr. Hilton, what you presented is more or less it is a theoretical type of thing. But one thing I would like to bring to your knowledge that if there is some change management we need, then the innovators like your Mind Excellence, they will have to take lead and they will have to convince the organization what is the necessity of this change. And once the organization is ready to accept the change, then only this process starts. So Mind Excellence on its part, if it has done something differently so that the change can be accepted by the organization, then you can pinpoint some those points as far as Mind Excellence is concerned.
This is where we can do a baseline audit of your operation, because sometimes we don't know what we don't know in our own organisation, and to have an audit with a second pair of eyes, do the analysis, look at the cost or the lost opportunity in production that we have, and then quantify and put a value to that. That means the science, the numbers, guides the business for the right decision. Not emotion, but the science delivers the answer for all of us to consider. So I agree. We must be able to have evidence for the business, evidence for the leadership to make these decisions. And yes, we base that in the scoping session so that we have it clearly identified and the expectations that are reasonably expected are identified. Each level of the project implementation will go through stage gates, and you will not shortcut proceed to another step until you have met that agreed stage gate. Theory, no. Practical, yes. This is how we choose to make the business develop, grow, and have continual improvement of deploying technology, education and training throughout the business and throughout our industry.
Okay, sir. Thank you.
Thank you, Mr. Hilton. It was very informative for our audience. So now, I think the organizer mandated us at 11:15 to close. We are 5 minutes early.
Please.
So I will give back to the organizer for conclusion.
Thank you so much, sir, for completing the session and concluding the session within deadline. I request all the participants to please put your hands together for the chairman, co-chairman, and rapporteur of this session. As we draw the curtains of the technical session centered around the digital transformation in mining industry, it is only fitting that we take a moment to express our heartfelt gratitude to those who have enriched our minds with their insights and expertise. Our deepest thanks to each and every speaker who graced this platform, sharing their knowledge and perspectives on the pivotal theme of digital transformation in mining industry. Your presentations have been a driving force behind the success of this session. We have with us our DTO sir, Shri Jitendra Malik sir in the audience. I request all of you to please put your hands together to acknowledge his presence. We have Shri Professor Shri S.S. Rai sir from IIT ISM Dhanbad. I request all of you to please once again put your hands together to acknowledge his presence. Now I request our chairman sir to please felicitate the speakers. First of all, I request sir to felicitate Shri Pradeep Kumar sir for his paper on design and development of high performance wear resistant tooth point assembly for excavator working in Opencast mines of NCL. Okay, no problem. I request sir to felicitate Atmaram Sahu sir for development of maintenance policy 4.0 of HEMM using Bayesian network model. I request all of you to please put your hands together for this distinguished speaker. Thank you so much, sir. Now I request co-chairman sir to please felicitate Piyush Singh sir for his paper on production and productivity improvement from 20 to 26 meter cube dipper rope shovel paired with 186 MT truck. I request all of you to keep having a resounding rounds of applause. Thank you, sir. Now I request Suman Saurabh sir to please felicitate Santosh Kumar sir from Khadia area of Northern Coalfields Limited for his paper on digital initiatives transforming Khadia. Thank you, sir. Now I request Chairman sir to please felicitate Pradeep Kumar sir on his paper on design and development of high performance wear resistant tooth point assembly for excavators working in open cast mines of HCL. Thank you, sir. Now I again request our chairman sir to please felicitate co-chairman of this session, Shri Rajiv Kumar sir, Area General Manager, Khadia area. I request all of you to please put your hands together for co-chairman of the session. Sir, your dedication to advancing this discourse, your passion for innovation and your commitment to sustainability has left an indelible mark on this conference. I once again request our chairman sir, Professor Devashish Dev sir, to please felicitate reporter of this session, Area General Manager, Krishnashila area, Shri Suman Saurabh sir. I request all of you to please put your hands together for reporter of this session. Thank you so much, sir. We thank our chairman, sir, Shri Professor Devashish Dev, sir, from our heart. I thank you, sir, for concluding the session within deadline. On behalf of organizing committee and all the attendees, I sincere thank to all the esteemed speakers of this session. I request all of you to please take your seats in the hall. Your efforts have undoubtedly elevated the quality of this international conference, 6th International Conference on Open Cast Mining Technology and Sustainability, ICOMS 2023. Let's express our collective appreciation with a rounds of applause to those outstanding contributors to our knowledge and understanding. For the next 4th session of the ICOMS 2023 on operational benchmarking and open cast mines, I hand over the podium to Mr. Vijesh and Swati.
Thank you, sir. Good morning, ladies and gentlemen, esteemed guests, and fellow enthusiasts in the field of mining and technology. I welcome you all to the 4th technical session of ICOMS 2023. The theme of the session is operational benchmarking in open cast mines. I'm sure that today's session shall be groundbreaking technological seminar that dwells into the revolutionizing overburden removal and coal evacuation. Today, we are honored to present a series of cutting-edge topics that explore the intersection of innovation, safety, efficiency, and sustainability within the mining sector. Our first presentation focuses on the theme of augmenting overburden removal by departmental capacity utilization with optimization of mining parameters for 20 CEM shovels in Northern Coalfields Limited, presented by our Honorable DTO NCL, Shri Jitendra Malik sir, and Shri Dinkar Tiwari, NCL HQ. Through this, we aim to unravel the potential enhancements in the capacity utilization by strategically optimizing mining parameters, offering insights into the landscape of advanced overburden removal. The second technical paper, we explore the techno-economic feasibility of mechanical rock excavators as a promising alternative to the conventional blasting close to the urban areas. Presented by Nachiket Bagade sir from VNIT Nagpur. This presentation introduces a novel methodology for dealing with the hard abrasive rock mass, shedding light on the economic viability and environmental sustainability of employing mechanical rock excavators in challenging proximity of urban settlements. The third paper, the energy productivity of surface miner using during the cutting and optimization of its control factors using Taguchi method, presented by Nilesh Prasad Pratap Singh. The next paper, measures to improve the productivity of NCL projects, presented by Shri LP Godse sir, GM Production and Safety, NCLHQ, providing a comprehensive overview of the strategies and technologies aimed at elevating the productivity levels within NCL projects. This discussion will unravel the innovative solutions to overcome challenges and enhancements in the project performance. Intriguingly, we delve into the realm of the maintenance with the fifth paper, the innovation-based maintenance, a case study of the 3372 Somnath dragline deployed in Kadia, the biggest dragline of Coal India Limited, presented by Shashi Ranjan sir, NCL Kadia. Through this case study, we unravel the intricacies of maintaining and optimizing the colossal 3372 Somnath dragline, demonstrating how innovation in maintenance practices can contribute to the operational excellence. The last paper, the optimization of dragline operational planning and sequencing for the productivity enhancement, a case study. Here we present a detailed examination of operational mining, planning, sequencing strategies, showing a real-life case study that highlights the tangible benefits of optimizing planning in enhancing the overall productivity. And last, we have the paper on technological control aspects in coal edge damage loss due to cast blasting in the dragline high wall, offering valuable insights into the mitigating damage risks associated with the cast blasting process.
It's time to gear up the technical session C. In order to start the proceeding, I shall take this opportunity to invite the chairman of the session, Professor S.S. Rai sir, IIT ISM Dhanbad, to the dais. Put your hands together for S.S. Rai sir. Professor S.S. Rai sir has done graduation from IISM Dhanbad. He has master's degree from Mines Paris Technology, France. He is an industry professional turned academician, over 28 years of global mining industry experience and over 5 years academic research experience over the mining value chain from exploration through the mine planning and design, operation and maintenance, and mine closure. With his special expertise in developing sustainable mining operations based on robust ESG principle and the application of cutting edge of the surface mining operation. He is also a member of the Environmental Appraisal Committee EAC of the Ministry of Environment, Forest and Climate Change. Most welcome, sir. I now request the co-chairman of the session, Sri Vinod Kumar Singh sir, Area GM to the dais. Ladies and gentlemen, put your hands together for the Area GM to the Chua. Sri Vinod Kumar Singh sir is an hugely experienced in coal mining industry and has led Tudhichwa area to greatest height of the coal production growth and sustainable mining operations. I shall also invite the rapporteur of the session, Sri Indrajit Singh sir, Area GM Bina, to the dais. Please have a huge round of applause for Indrajit Singh sir. Sri Indrajit Singh sir, Area General Manager Bina, has immense experience in coal mining sector from across CIL subsidiary. Under his eminent leadership, he has set several benchmarks in coal production, coal dispatch, and has ensured giant leap in environment management at Bina area. The first paper is of our Honorable Director Technical Operational, Sri Jitendra Malik sir. And with his blessing, I would like to invite sir to the dais, and he will be presenting the paper whose title is Augmenting Overburden Removal by Department Capacity Utilization with Optimization of Mining Parameters for 20 cubic meters soil in Northern Coalfields Limited. Put your hands together for Director Technical Operations, Sri Jitendra Malik sir. For the second paper, I would like to invite Nachiket V. Vagade, PNIT Nagpur. Most welcome, sir. And he will be presenting the paper Techno-Economic Feasibility of Mechanical Rock Excavator as a Promising Alternative to Conventional Blasting Close to Urban Area, a Novel Methodology for Hard Abrasive Rock Mass. For the third paper, I would like to invite Sri LP Godse sir, GM Production Mining, NCL HQ. Put your hands together for LP Godse sir. And he will be presenting the paper Measures to Improve Productivity at NCL Project. Now, I hand over the mic to the chairman of the session to start the session with the proceeding. Over to you, sir.
Thank you, ma'am. Thank you, the organizers, for the opportunity and chair a session. Quite interesting topic, professional benchmark. I was thinking, what is benchmarking? And going through the internet, one of the definition it's a quite common practice today worldwide. It's benchmarking. Follow the process that we understand our own business processes and then compare it with the industry leaders who are in these processes. They are the leading. They are having the best practice. And identifying the gap, this performance improvement process continues, a continuous process. So, but the first we do any benchmarking, it's important to understand our own process, how we are doing it, what are the different losses that we have, different techniques like one is time limit. There are different techniques, but first job is to understand how that we can compare it. So quite interesting topics are there in this session. I think 7, 6. There are 6 topics, and from different areas, like starting burden operational performance, then to the maintenance, and also it is on the interesting drilling and blasting topic, which deals with the cast blasting and the process how to stop the damage of the by the. So with these words,
thank you, sir. Morning to all. The first presenter is the Jitendra Malik sir, Director Operation NCL, and the topic is augmenting tree removal by departmental capacity utilization with optimizing of mining parameters for 20 cubic meters soil in NCL. Our request, sir, Jitendra Malik sir, please present. And the time is 20 minutes, sir.
Morning to all. The topic for discussion: augmenting overburden removal by departmental capacity utilization with optimization of mining parameters. Authors are Tiwari, Kumar. Even though we may brand coal as dirty fuel, but we Indians has to continue and be the prime source. In COP 25 and then in COP 8, India came up with firm decision that we are not. And with this, India has to pay a major
was assigned a task of 135 million tons. T20. All know we have now pushed it up 137. And in the coming years, has to be around about 140. With much of production and stripping ratio as 6:1. We have to scale up our operation. We have a larger volume material. For this, if we buy with lesser priced equipment, of traffic congestion, of breakdown. Sir Rai was speaking about benchmarking, but very much convinced that our marking benchmark points. I remember came here of very has the mark. Then right that the per day but higher level. Without much time, just right and nice shower and
Thank you very much, sir. It has been always an honor to be a part of ICOMS team, and it is going to become a exemplary thing for me as a mining engineer if I can guide the company in the right direction. When we talk about today, it seems a little gloomy, but when we see the future, it seems a little bit more darker side. When we talk that where do we stand as NCL in 2047, the fundamental question that rises into my mind is that we stand at 2047. And if we plan to do that, if we have that aspiration to mark our presence in 2047, we need to ensure what our Honorable CMD sir has said yesterday, that we have to enhance the production from the departmental equipment. When I say departmental equipment, SS Rai sir was mentioning yesterday that NCL is the mecca of dragline operation in India. Absolutely true. The fleet of 23 at NCL, we are the mecca of dragline operation. But now the mecca needs support, sir, with the two pillars. One that is held by our own hierarchy of dragline, but the second is going to be replaced by 20 cubic meter shovel in congruence with the 190 tonner dumpers. When we talk about 190 tonner dumper and 20 cubic meter shovel, there are plenty of challenges that we have with us. Next. One is that earlier Russians have planned this NCL with a maximum production level of 76 million tons. During 1976, CMPDIL came further, they said no, we can reach up to 87, but we are standing here with the same mine with a production of 135 or going to touch 140 as DTO sir has mentioned, but how we are going to do that? One fundamental question is that we are a subsidiary which handles the maximum quantity of overburden removal. That last year it was close to 465 million cubic meter, if I might be there plus or minus 2%. But this figure is going to touch close to 510. With the 510 million cubic meter of overburden removal, we have outsourcing with us that is contributing, last year it has contributed 78%. 78% from the outsourcing means if one day outsourcing companies that try to make themselves kind of autocratic regime, he might face a little bit hurdle. Now, what potential we have in terms of HEMM numbers? We are one of the largest. We have been spending tens of crores. As you can see in my screen, it is a schematic diagram just talking about the Moher sub-basin, an area which is spread around 312 square kilometers with the 10 mines, one additional the yellow patch that is done by Sasha. Here, when we going towards the depth is going to increase from existing 250 meters to additional 350. Now if we are going 100 meter deeper, means the overall lead length is going to more than 25%. Now, if we have to cater this lead length of 25%, there are two options. One, to deploy your departmental equipment, maximize their presence so that the overall traffic density or the safety angle of the mine is compromised. Moving further, NCL as of now is a company with 20 numbers of 20 cubic meter shovel with 145 190 tonner dumper in its operation. As of now, as per the CMPDIL norms, this 20 cubic meter shovel and 190 tonner dumper was supposed to produce 4.86 million cubic meter of burden per day. Calculating it 2 by day, it comes around 14,500 cubic meter per day. Are we producing that much? I barely see that. Now, why it is happening? What is the problem lying that we are not able to optimize, utilize the resources that we have? In this, and this was tasked upon us by Honorable CMD Sir, our Director Sir, and I would like to acknowledge one of the biggest contribution behind this paper by Sri Umakant Yadav Sir, General Manager Excavation, who has given his thought. No, there is some synchronization required between the projects, and that synchronization should be supported by the technical backing. The technical backing that includes mining system, the planning parameters, and finally the blasting parameters. What are the front ending required and foreseen? And I'll be trying to talk more on that. Next, please. Before talking about that, I would like to take your kind attention to these three figures that is presented in the screen. One is 1,009.29 rupees per ton. That's the cost of production we are having. 1,000 rupees per ton in an open cast mine, that's a huge figure. And we have been increasing with the growth rate that we are having in our overall production level. Is this a sustainable figure? I would say the financial experts might be sitting here, they might say no. Yes, they agree. Because there is a lot of work required to ensure that operational cost is cut down by at least 20 or 15%. As of now, let me tell your kind attention to another figure that is 78% last year. Burden removal of NCL was most of them were supported by the HOE company. Last year they have contributed 78%. But their cost component is only 30%. You can see from that the HOE cost was rupees 303.43 per ton. It means they are taking just 30% of your cost, but they are bringing operation of 80%. That's a huge gap. And this gap has to be closed down, narrowed down, and I think yesterday only CMD Sir has said that we need to ensure that we touch this percentage from existing 22% to at least 40% from the departmental equipment. And for that, need to have the maximization in operation from 20 cubic meter shop. Third is the financial burden that we are having. That was close to 4,000 crore that we have to actually operators. Next, please. As of now, we are a company who has been achieving 6.5% CAGR for the past 7 years. For a company sizing NCL, that's a huge achievement. Because none of the other company or any subsidiaries of Coal India has achieved so far. But our aspirations are high. Our 1 BT production target given by Coal India is 135 million ton. We are going to achieve that. But is this growth sustainable? Are the current level of production from the departmental equipment sustainable? That's the bigger question that we are going to ask. Starting from the technical aspect, what are the factors that affect the selection of equipments or HEMM that we are going to deploy? So there are plenty of them. I have listed down 8. One is the thickness of overburden layer and gradient of the sea, pit geometry, strike length, rate of overburden removal, to have life of the mine, geological disturbance, and capital ability. Luckily, we are blessed with a very good geotechnical condition at our subbasic. Need to have relatively flatter seam, and it should have thickness adequate to make the mining sustainable. Starting with the first aspect that I have touched, mining system, where we need to deploy our 20 cubic meter shovel in order to ensure the maximum output. As you can see, I have tried to represent the entire Opencast mine in a single slide, where the right side is showing the progression of the mine, left side is showing how we are actually moving from the mine. Now, in NCL, there are 3 seams. One is Reva top, Kureva bottom. Here that I have taken this figure from Nigai mine so that you can see the merge both of them, and the Turra mine. Between Kureva seam and Turra seam, there is a overall parting of 55 meters. 27 to 30 meter are met by the drag lines, but there are upper 20 meter where we are having a mix and match. Mix and match, when I say some of the areas are excavating this with the help of HOD. Some of them are from departmental. There is no synchronization there. I just recall that yesterday Dev sir was quoting a mine that is fully autonomous in Australia, if I'm not wrong. If we want to make our mine autonomous, we need to bring that machinery or manufacturing like automation synchronization in terms of mine operation. That each bench is separated, each mine is having its own designated area, and they are working without any much disturbance. And I believe I have been following that mine. They have developed an area where all the equipments are having their designated area. They do their operation. The marching is low. The overall life
Mr.
of the
Tiwari, come fast. You have to cover within 5 minutes. Next.
Sure. Next, please. So this is where I am proposing that the parting between Breva bottom and Turra is to done with the help of drag line from the bottommost part, and between that parting should be carried out by this 20 shovel. Next. As of now, we have 4 models of shovel, and the total number is going to be close to 22, I think, in the next year. And the dumper population, we are having 3 model, 519, and the current strength is close to 145. So there is a good combination left with us that can actually augment the overall operational benchmarking and faster. Next. So what we have done is trying to define parameters. Earlier we have taken what is the potential of a 20 cubic meter shovel. Currently we are considering that the CMPDL norms are governed by is working 8 hours a day and 3 shifts a day. As of now, we are having the rock category of like category 3 is comprising 90%, and the category 4 rocks are 10%. For that, the rock shovel availability was considered to be 80%, and we have considered the utilization close to 8%. Overall factor, system factor is considered to be 0.8. For that, we are proposing that we have that shovel bench close to 20 meters, and that shovel bench should not be moved quite often. Should not be merged quite often, because there are 3 factors to that. One, the cycle time of this entire blast takes away a lot of time of operation. 2, when we minimize the operation, the chain length or the chain sprocket life is enhanced. So this is the system that we are proposing, sir, that we are going to have a height after blast 18 meters, 90, and this 5 mines are having these system. They can actually, overall augment that whatever conditions suit for them, achieve the 14,500 cubic meter a day production they can achieve. We have done bifurcation for the 2 different cut length. One is for 75 that we find that is the maximum productive. Another for the 70 meter. As of now,
Conclude.
I would say in minute or this, I would talk about it.
Silver a little fast. Yes. Okay.
So NCL, we have tried to analyze whether the CMPDIL norm is the maximum. So for that, we have tried to understand, no, there is a further growth or the, the scope of improvement available. I think we can actually have more than 4.86 million cubic meter of production from. In future, we are planning to cut down this gap between the match factor between towel and this dumper, and you can see from the last column of the top chart that as of now we are having 7.16 as the system factor match factor, and by 24-25 it is going to touch 6.59. So now talking about the blasting parameters, we have taken the conventional blasting parameters, depth of meters, the block size, we closed 20-75-100, and the blasting frequency is very, very important, that we need to reduce the blasting from existing 8 times a month, barely 3 times. With that, we can actually augment the operational benchmarking from 20 shop. Next, please. What benefits we are going to? One is that if you have a wider length, you can actually ensure the double side. Second, the marching is ultimately marching cured in the track chain life. Also analyze what is carbon saving that we have analyzed, that if say 50 million cubic meters of overburden removal from HOE contracts machine, we are actually saving 370 tippers running in the mine, making it more safer. We are cutting down 170 kilotons per year from these mines. The idling is going to start, and the most important, that cost competitiveness in short. Next. As a company, to ensure that we touch the higher heights, because at mining we face first rather than learn. First phase, then we learn, and then we get better. This operational plan is touching the 3 very important aspects, out of which 2 are directly impacted by these operations. One is the coal production potential, and second is the operating cost. And this is the figure I was talking about. None of the shovels have actually touched their potential production level. So next. Thank you very much. I think I have come in time.
Thank you, Mr. Dinkar. Any question from the audience, please? माइक दीजिए, सामने भारतेंदु साहब को माइक.
मेरा 2 क्वेश्चन था. Have you analyzed what is the reason of getting the child level? Second, the cut should be the last 15 to 2 years. That cut, that is one cut of that. Earlier than guiding just the
grinder system का height है
to 75 meter average.
Yes, sir, I have it.
That's right. That's 50.
Umakant Yadav, sir.
Please show that slide. Then I would like to add something. Last, there is yes. Can you that part only? Previous, it is as Bhatandu Sahab is saying, mostly in NCL, the track line width varies from 75 to 85 meters. It is a particular case in which we have considered 75 meter of drag line bench, and hence the sawmill bench is also similar. Everything it is synchronized.
if you take 80 meter of drag line bench, then we can take 80 meter of sovel bench also. If you can 20 meter of drag line bench, then the width of the sovel bench will be 70. So it is complete synchronization. As far as the 20 to 20 meter passage is left, for a working drag line of 2496 capacity, 40 meter is a standard length passage width, but that is so that the drag line can march from sitting. But 20 meter, once if you need to march the drag line, then the 25 meter will be less for passage of the drag line. So always in planning we take 30 more than 35 meters, and 45 is optimum. 40 meter is optimum. That's why 40 meter passage, that is corridor, has been taken. And as far as this planning heights are considered, if we see that there are 20 total height of the parting is 55 meters, and the one dragline bench is 35 meter and 25 meter is sovel temper bench. If you blast 20 meter bench of the sovel, it comes to around, after blasting, it comes to around 17 meters. That is perfect height, matching height for a 20 meter cube sovel for digging. And for the same manner in NCL, to expose to get quantity of coal at presently 80 to 28 to 30 meter height is considered, so that the exposure of coal from the Tura seam will be maximum. In this case, as height is taken at 35 meter, but after blasting, throw will be there, and the reduced height will come to around 30 to 29 to 30 meters. That is optimum, so that it will not disturb our exposure of coal. We have taken everything in consideration, and this has been planned in such a manner that there will be complete synchronization between the sovel benches and dragline benches, and without putting any other machine on the parting phase. So any activity that is in the mine, only the two combination will be there, dragline and sovel in the parting, and above that you can put anything. So this area has to be kept away from the HOE activity, and in that case we will produce maximum output from this area, this parting area, and maximization of the productivity will be there. Okay, thank you, Adar sir. Any more questions?
In order to answer the first question. Yeah, first question, sir.
It's true that the recommended corridor is 40 meters, but because of various constraints, we are unable. That's why I have said that corridor we are in the practice of. And my question was specific that the total length of the cut. If you want to synchronize, height is true, but that is not going to affect the yield. If you want to synchronize both dragline cut with sovel cut, it should be around 80 meter. Standard is 80 meter. Dragline cut in NCL. 80 meter plus with 2496. With 2090, we are taking 70. Or with that 80 plus 40 or 100 meter, I think that first part is.
The first part. One is that the availability of this, because the operations are not standardized, blasting operations, but sometimes that 20 cubic meter is running at a bit. Second is as of now there is certain mismatch between presence of 190 ton dumpers and 20 shovel.
Like to add, there is no harm in taking 80 meter cut widths. If there is a plan of 80 meter, because dragline balancing of cut is it requires approval from DGMS. If any mine is having 80 meter cuts, then there is no need to change to 75 meters. It will go on 80 meter cut. If it is 85 meters, it has to go on 85 meters. But accordingly, we will adjust the sovel bench width, and there is no harm in taking any width if it is comfortable for the planned purpose, plan and DGMS approval.
All are facing shortage of dumper. Dumpers are
just to add some, I think the topic here was to enhance the productivity. As the this explained, this was to basically make space for the dragline. It's called the step. Most of it is coming from for the planning point. Whereas question should be how to achieve 450. Anyway, you operational bottlenecks one aspect that can be back of that. Our dumper runs how much maximum should be. Fair enough. All of them. Because benchmarking is a process of comparing yourself with the best practice. I was looking for availability 80%. The utilization 80%. Multiplied the two. You are benchmarking your operation of shovel working hours, annual working 5,000 or 4,000. I think we need to challenge. Unless we challenge that, because there are two productivity. One is the early productivity. My shovel operates, how much it that depends. Second, the annual productivity, which comes how much is action. These are the two area. But anyway, thank you very much. It was a nice presentation. We can move on to the second one.
Thank you, sir. Thank you, DTO sir. Now I request
Sir.
Professor Murthy.
Allow factors. There is an availability of very old knower at 5%. Number was not. Due to passage of time, now there is enough friction. Second factor, there is again input power side. 70.5% cycle time of by 37.56%. There is friction from passive 5 seconds. And with four relation of the T will bring in the above T.
Just that talked about shear plant is that planning was back. Things have changed. A lot of water has flown after. Farming. In all those factors. Okay.
Thank you, sir.
Good morning. Good morning, sir. सर मेरा एक्सपीरियंस है 20 क्यूबिक मीटर पे
और बाद में डिस्कस कर लेना है बहुत it will be better. Now I request Professor Murthy to kindly.
Good morning, sir. My name is Nachikeet Bhagade. Thank you very much. I first of all welcome at ICOMS. My name is Nachikeet Bhagade. I am an assistant professor at PNIT Nagpur. Paper is co-authored by Professor VMSR and PD Rathi sir, Ji. So this work is actually about designing a novel methodology, excavate hard abrasive block mass, goes to urban dwellings. Now, because excavations are on the rise, even near urban dwellings near cities, where there are stricter restrictions of tie rods ground. So here I'm going to discuss regarding cutting and how we can navigate the difficult restrictions of vibrations, tie rods, and so on, and by slightly avoiding, not completely avoiding. So wide applications of blasting, it's widely applied in mining, quarrying, tunneling, building foundations, trenching, underground space creation, and underwater blasting. The initial couple of slides I'll be moving very fast. Disadvantage of blasting includes, all of us know, ground vibrations, noxious fumes, fly rocks, boulders, backbreak, and so on. But however, these disadvantages are not completely eliminated even by controlled blasting techniques such as pre-split, buffer, smooth blasting, trim blasting, line drilling, because the explosive itself detonates at a very high velocity, around 3500 to 4100 per second, and generates a detonation pressure as high as 10 gigapascal. So it is not very feasible always to completely eliminate ground vibration and noise. So blasting engineers, excavation engineers have resorted to a very viable option such as cutting, which is very popular. The advantages of cutting include it removes all the major disadvantages of blasting, no ground vibration, no backbreak, no boulders, no fly rocks, so on. But however, there are cons of cutting. Some disadvantages of cutting include one major disadvantage is pick wear, which is seen in very abrasive rocks which have high cut quartz. It is inflexible because the design of excavation machines is very site specific, produces dust, and is also has a good sizable investment at the outset. So there are two scenarios here: mining and urban excavation. Even as Opencast mines are reaching deeper horizons, and reaching their break-even stripping ratio, they are getting transformed into underground, which require new innovations and technology to excavate the mineral and even in urban excavation, as excavations are taking place closer to the cities, closer to the urban dwellings, we need to come up with some combination of blasting and cutting, or completely taking shelter of cutting, excavate very close to urban. So surface miners are very extensive in limestone mines, particularly in limestone mines in India, and it has applications in coal mines also, and it will include CL, SCCL, and CCL in India. CL also has. Yes. Surface mine. This is a typical schematic of surface miner. We have a cutting drum at the bottom, and the cut material is conveyed on the conveyor to the dumping area. So a surface miner is environmentally friendly because it eliminates ground vibration, no fly rock, no noise. It gives us well graded material preparation, and it can be deployed. Thus, it can be deployed very close to unsupervised. However, disadvantages include very high abrasivity rocks like even sandstone. There are some sandstone which have high quartz content. Longer cut lengths can make surface miner deployment uneconomic, and harder rock, which means rocks with harder, higher UCS, can lead to pick shout breakage and ultimately lead to poor performance surface miner. So yes, next. So this is just an comparison of productivity of two different OBs, OB less than 5 megapascal and greater than 15 megapascal. So we can see here that the hourly production is higher for the softer rock. Please. Owning cost per 1000 cubic meters for OB less than 5 megapascal is also lesser, and in case of harder rocks, which has where excavation is much more difficult, so it is little costlier. Next. The generic specifications of surface miner: drum width, machine power, drum width approximately 7 meters, machine power 2500, 2.5 megawatts, weight little more than 180 tons, rated capacity 2400 per hour, maximum cutting depth 1500 mm, and gradient varies between 1 in 12 to 1 in 5 degrees to 11.
1 minute, sir. Due to some engagements, our Director Technical, Sri Jitendra Madhya, sir, is in this hall. I request all of you to please put your hands together to acknowledge his presence in this hall. Thank you so much. Sir, you can continue.
Thank you.
Thank you, sir. I request all the participants to please be seated and listen to the exciting presentation of Shri Bagale, sir.
This is just a selection criteria of drum cutters. So here I am showing a classification system or a selection criteria of drum cutters, a plot between discontinuity spacing versus point load index. So point load index is very pertinent in this case because the drum cutters have pick shafts, and those picks are actually penetrating the rock mass. So therefore, the point load strength index is very pertinent in this case. So now you can see here this plot where the point load index, with the increase of point load index and the increase of discontinuity spacing, we can see that blasting is inevitable. We cannot avoid, or we cannot avoid blasting in case of very massive and very hard. Similarly, for softer rocks and which are more laminated, which are more jointed, we can use the digging. So we can definitely implement drum cutters. So there are a couple of lacuna in this classification chart. I would like to spend some time here. So one point is that this chart does not consider anything about abrasivity of rock mass, which is a major consideration in cutting. Number two is that the productivity of any drum cutter, typical drum cutter, is very much influenced by the direction of cutting with respect to the orientation of joints. So that has to come into the picture. And so yeah, next, please go ahead. So these are a couple of lacunas, and to improve upon these lacunas, we there is another classification which was suggested by Day and Bose, right? The rock mass cuttability classification, which takes into consideration rock mass, machine parameters, and operation parameters. Machine parameters mainly machine power, and operation parameters is the direction of cutting with respect to the shape and size of the block, and the direction of tip and strike, the direction of joint into. So this is an arithmetic sum of the point. So these are ratings basically. So these ratings, they add up, and cuttability classification was suggested. Point load strength, please. Point load strength rating, volumetric joint count, abrasivity index. So the first three are basically the rock mass parameters. Next is JS, index for direction of cutting with respect to joint orientation. This is the operational parameter. And capital M is the index for machine power, which is a machine. So this is a chart. So you can see that the class 1 has lower values, which suggest very easy digging, easy dipping, and the class 5 has higher values and suggest hard diggability, hard dippability, and the deployment of surface miner is not very much suggested. So higher values of cuttability index, surface miner should not be deployed, whereas lower values are favorable for cutting. Hydraulic rock breaker is another option which is quite popular in such urban areas, excavating near urban areas. So basically this consists of a moving piston vertically oscillating up and down, striking a tool, and that tool touches and penetrates the rock, which creates stress waves, thus breaking the rock by tensile breaking. Right? Next. So actually Toranio has conducted a research on comparison of the efficacy of blasting and efficacy of hydraulic rock breaker, and suggested that the combination of two has given good control ground vibrations and noise, and good fragmented at the end of the excavation. This I am showing a generic specification of rock breaker. Impact energy ranges generally from 34 to 100 kilojoules, blows per minute 7 to 16 blows per minute, weight 3.5 to 12 tons, and operating pressure 140 to kg per centimeter square. So there was another research that was conducted which compares the efficacy of rock breaking with blasting, and it was seen that the rock breaker was actually able to excavate 1 meter cube more effectively at a shorter time and reasonably less PPV and frequency and stuff. Vibro ripper is another option which uses two eccentric rotating wheels. These two rotating wheels are actually they counteract their horizontal force, and they add the vertical force. That vertical force is used to inflict vibratory force on the rock mass, which inflicts damage and which inflicts fragmentation. Yeah. So therefore, the degree of fragmentation is actually proportional to the angular velocity of the two eccentric. Yes, next please. So this is please go back. This is a scheme. Yeah. So this is basically an attachment to any excavator. Just as much as hydraulic rock breaker, vibro ripper can also be used. So yeah. So another is pyrotechnic. Pyrotechnic is an explosive, but it's an explosive which does not detonate, but it deflagrates. Like explosive, like I said in the beginning, the detonation pressure is very high, 10 gigapascals, and it detonates at the high VOD, 3.5 to 4.5 kilometers per second. But pyrotechnics have a lower VOD, and they produce only 300 megapascals of pressure. So, and the specific charge also used is quite less, 0.1 to 0.15 kg per meter cube, and therefore they naturally generate very low levels of vibration and low levels of noise. However, the fragmentation is quite compromised. We'll see.
Please sum up.
Yes, sir. Just give me. So the primary advantages I've already discussed. Go ahead. So I'm just comparing here the properties or the characteristic features of pyrotechnics with conventional high explosive. The the main difference between these two pyrotechnics and explosive is due to the fact that the pyrotechnics are not detonating but they are deflagrating. So therefore all the cons of the blasting are downscaled, whereas the breakage part is slightly compromised in terms of fragmentation. So this is a study which was conducted at Palam, where the conventional explosive was compared with pyrotechnic, and we can see that at scale distance, this is a plot between PPV and scale distance. At scale distance 10, square root scale distance 10, the near field ground vibration was exceeding the for pyrotechnic was exceeding the conventional, and after that it became lesser. So therefore, we can say that pyrotechnic is much more useful for complying to the vibration standards as compared to the conventional explosive. Again, because of its deflagrating. So a novel methodology I'm suggesting in the end is a very crude methodology without any detailed ramifications. This is yet to be implemented. So hard abrasive rocks, if you are encountering near human dwellings, we can use partial fragmentation. We can create partial fragmentation using pyrotechnics, and later on further fragment the rock using hydraulic rock breakers, and which will ultimately give us a well fragmented rock environment.
Thank you. Question from the audience delegates. माइक आगे दीजिए.
Acha, Nachiket, when you are comparing pyrotechnics with the conventional explosives, then yes, go to that graph. The last graph. So actually, seen that there are only limited points for the pyrotechnics.
We are not able to see the graph.
Yeah, 33 slide. Yes. So you have only limited points for the pyrotechnics. Yes. So how can you compare actually? Is it your graph or you have taken literature?
No, sir. This is my work. Okay. Actually, study was conducted in near Palam area for creating a foundation for aerospace museum. Actually, sir, they were skeptical about the use of pyrotechnics. It was a pilot study, and they were only using couple of pilot tests. That's why we have limited data for.
Cannot have any comparison because it's
so this is a trend, a very rough trend analysis actually. You are absolutely right. Thank you for that.
You cannot make a generalized statement like that. Unless you make a comprehensive study, you cannot make it.
Thank you.
Thank you. Thank you. Nachiket.
Thank you, sir.
Very good. Sir. Sir, what? Slide.
Thank you for the question, Pratik. Actually, like I showed you in the chart of the selection of drum cutters, we can see that we don't have any other option in case of very hard abrasive rocks. Abrasivity is one thing and higher compressive strength is the other. When you combine these two problems in one single rock mass, we don't have any other shelter left apart from blasting. So cutting is an option, but blasting is the major thing that we are that is the real bread and butter of any excavation engineer. That is what I have seen in my limited experience of field and research. Thank you. Thank you. Thank you.
Thank you. Next topic is measures to improve productivity at NCL project. To be presented by Sri LP Godse sir. And this a request you to.
Good afternoon. Good afternoon, all and one. पेपर क्योंकि ये सेमिनार है सस्टेनेबिलिटी का और जहां तक मुझे याद है कि हर साल वही एक आइडिया वही एक पेपर हम लोग यहाँ पर प्रस्तुत करने का मौका मिलता है और करते हैं। बहुत थ्योरी के बजाय हम लोग प्रैक्टिकल चीजें जो देखते हैं उसी के बारे में बताते हैं और उसी के बारे में शेयर करते हैं। ये शेयरिंग का प्लेटफॉर्म। तो सब्जेक्ट के बारे में ब्रीफ में बताने के पहले नेक्स्ट स्लाइड। ये स्लाइड मुझे बहुत पसंद है। अगर आपके पास 100 रुपया है, मेरे पास 100 रुपया है, अगर हम लोग नोट को बदलेंगे तो आपके पास भी 100 ही रुपया रहेगा, मेरे पास भी 100 ही रुपया रहेगा। लेकिन आपके पास अगर एक बेहतर आइडिया है, मेरे पास एक बेहतर आइडिया है, अगर हम लोग एक्सचेंज कर देंगे तो आपके पास दो बेहतरीन आइडिया हो जाएगी, मेरे पास दो आइडिया। इसी थीम में 2018 से जब आईकॉम हुआ हम लोग पेपर प्रस्तुत करने का मौका मिला। इस बार भी सस्टेनेबिलिटी है एनसीएल में किसी ने कोई बोलता था कि तो 130 से अधिक नहीं हो सकता है, पोटेंशियल नहीं है, दिस नहीं है, दैट नहीं है। आज से अगर कुछ साल पहले हम लोग देखेंगे तो 10 प्रोजेक्ट में से 1, 2, 3 प्रोजेक्ट जरूर कहीं ना कहीं प्रॉब्लम होता था, फेल करते थे, कुछ वजह रहती थी कुछ। लेकिन विगत 2000 करीब 16 से आप ये देखेंगे 16-17 से ऑनवर्ड कोई भी प्रोजेक्ट यहाँ पर फेल नहीं। जब पोटेंशियल हमारा 130 का था तो ये चमत्कार कैसे हो रहा है। 131.17 लास्ट ईयर हुआ, इस बार शुरू में टारगेट रखा गया 133, फिर किया गया 135, फिर बोला जा रहा है 137। जेआरडी टाटा का कोट मुझे याद आ रहा है, एक सेमिनार में उन्होंने कहा था कि अंग्रेजी के जो अल्फाबेट्स 24 अक्षर है, अगर उसको 1 to 24 आप आंकड़ा दीजिए, सिर्फ 3 वर्ड है अंग्रेजी के डिक्शनरी में, एटीट्यूड, री इंजीनियरिंग और डिसिप्लिन। अगर इन स्पेलिंग्स को अगर आप वो देंगे मार्किंग तो देखेंगे कि यही 3 वर्ड है केवल, जिसका टोटल 100। यानी कि अगर ये 3 में से आप ये तीनों चीज को अगर अडॉप्ट करते हो, अगर आप जो भी सोचते हो वो जरूर होगा। मुझे लगता है कि एनसीएल ने ये तीनों को अडॉप्ट किया है। एनसीएल टोटली डिसिप्लिन में है। एटीट्यूड आप देख ही रहे, इतना बड़ा ICOMS का आयोजन फ्री ऑफ डेलीगेट फीस, फ्री ऑफ एनी स्पॉन्सरशिप कर रहा है। इससे प्रूव हो जाता है कि एटीट्यूड क्या है। रही बात री इंजीनियरिंग की, तो री इंजीनियरिंग में क्या क्या किया गया इस गोल को अचीव करने के लिए, 130 के ऊपर जाने के लिए क्या किया गया। इस बार इसी रोक रहा है, अदरवाइज हमें लगता है 138, 139 तक भी पहुंच सकते थे और हमारे लीडर्स जरूर पहुंचा देते। बट इसी के चलते, कंस्ट्रेंट के चलते हम लोग समवेयर वी आर लैंडिंग 135 पॉइंट लाइक दैट। अगर ये ईसी और एफसी का कंस्ट्रेंट नहीं रहता तो शायद ये चमत्कार इसी साल हो जाता। जैसा कि ब्लॉक बी में इशू हो गया है एफसी का, तो हम लोगों का 2 बिलियन का लॉस होने जा रहा है। इन द गिवन रिसोर्सेस, इन द गिवन मैन पावर है, मशीन नो डाउट कुछ ऐड होते जा रही है, हर साल ऐड हो रही है। एनसीएल ने ऐसा क्या किया है, ऐसा क्या किया है कि ये चमत्कार हर साल होते जा रहा है और अच्छे रेट से हो रहा है। यही आइडिया आपके साथ शेयर करने के लिए मैं मिस्टर पांडे को कहूंगा कि आप 1 by 1 एनसीएल ने क्या क्या किया और क्या क्या करने जा रहा है। क्या क्या करने जा रहे हैं ये तो बहुत कुछ नहीं बताएंगे, बट क्या किया गया एनसीएल में और कितना ग्रोथ हुआ, प्रोडक्टिविटी में हुआ, ओएमएस में हुआ। अगर मैं सम अप करूं तो हम लोग हर साल माइनिंग इंजीनियर्स यहाँ मैक्सिमम होंगे,
हम लोग हर साल जो है बारिश हो गया, पानी गिर गया, रास्ता खराब है, इसके चलते हम लोगों का डिस्पैच नहीं हो रहा है, ये जरूर बोलते थे। बट एनसीएल में अंडर द देन चेयरमैन सीआईएल ने सीसी रोड का प्रस्तावना दिया और हम लोग 75 किलोमीटर बनाना था, उसमें 36 किलोमीटर बन चुका है ऑलरेडी। उसके बाद डबल लोडिंग, मुझे लगता है कि चेयर पर्सन जो अभी होल्ड कर रहे चेयर, या गिवन सम पेपर ऑलरेडी, हम लोगों के सीएमडी साहब भी कहते रहते हैं कि भाई इसको आप इम्प्लीमेंट करिए सो दैट 15 से 20% का ग्रोथ उसमें मिलेगा। अगर आपने सीसी रोड बना दिया, पानी कितना ही गिर जाए तो मुझे नहीं लगता कि डिस्पैच मार होगा, अगर ट्रांसपोर्ट इन ट्यून है तो। उसके अलावा ब्लास्टिंग में भी बहुत सारा इंजीनियरिंग किया गया, एक्सपेरिमेंट किया गया। आदरणीय भोला सिंह साहब एक्सपर्ट माने जाते हैं इसके, उन्होंने बहुत काम किया है इस फील्ड में, स्पेशली ये चीज़ों में तो है ही, बट ब्लास्टिंग उनका बहुत पैशन है और काम किया उनने। के गाइडेंस में एनसीएल में टोटल जितने भी ड्रैगलाइन हो, शावेल हो, सोर्सिंग हो, उसमें रीडिजाइन किया गया ब्लास्टिंग पैटर्न। उसके चलते उसका फ्रेगमेंटेशन हो गया, उसका मग पाइल हो गया, वगैरह वगैरह। बहुत सारी डिटेल्स मिस्टर पांडे आपके साथ शेयर करेंगे। और क्या क्या किया गया, बहुत सारे पार्ट्स भी बने, उसका भी ह्यूमन बिहेवियर पे, ह्यूमन हेल्थ पे क्या असर पड़ा, प्रोडक्टिविटी में कैसे उसको लिंक कर सकते हैं विथ फैक्ट्स एंड फिगर्स। बहुत थ्योरी के बजाय जो हो रहा है, मुझे लगता है कि खड़िया में हम लोग थे, मिस्टर एस के जहाँ थे, तो हम लोग 35 मीटर करीब करीब ड्रैगलाइन को निकालने के लिए लास्ट में छोड़ते थे, लेकिन हम लोगों ने एक बार ऐसा किया कि बीच में डिकोल करके उसमें मिट्टी भर के साइड वाला 35 मीटर भी लिया, और ये अभी बहुत सारे प्रोजेक्ट्स में इम्प्लीमेंट हुआ है। बीना में डीसेलिंग प्लांट लॉस में था, उसको हम लोगों ने कैसे बिल्डिंग किया और कैसे उसको प्रॉफिट में लाया गया, एक क्वार्टर के लिए लॉस में था, इसका भी एक पेपर मुझे याद पड़ रहा है। उसके बाद ड्रैगलाइन में बूम में क्रैक था, उसका किस तरह से लोगों ने विदाउट नीचे करे बगैर कैसे वेल्डिंग किया, पुली जो आज भी चल रहा है, वगैरह वगैरह। ऐसे बहुत सारे पेपर्स हम लोगों ने जो प्रैक्टिकली हम लोग करते हैं फील्ड में, जो अडॉप्ट करते हैं सक्सेसफुली, सेफली, तो वही आइडिया, वही प्रैक्टिकल चीजें हम लोग यहाँ प्रेजेंट करते हैं। नाउ आई रिक्वेस्ट मिस्टर पांडे, माय कलीग, go into the details and share the ideas, share the works which NCL have adopted, and along with the results which we have got. Thank you. नलिनी बजा रहे भाई।
Thank you, sir. Respected CMP sir, DT sir, DTPNP sir, FDs, chairman, three members, dignitaries present here. Very good afternoon. Myself, Ajay Kumar Pandey, Manager Mining Production. This paper is basically discussion about measures which has been taken in NCL in various aspects to improve productivity of HEMM or all resources. Next slide. This is the introduction part. Productivity is basically the measurement of resource utilization to get desired output. Also relates output to input at various aspects of performance. From figure you can see how input is being converted into enhanced output. Enhanced part is nothing but a performance or productivity. Next slide. This is showing how processing and input is converted into enhanced output. Their power, material, machinery, and power capital, their all resources converted into output. Next slide. This is all measures taken to the productivity of HEMM in NCL in this financial year. Come to next slide. First thing which has been fragmentation. As we all know, fragmentation play a vital role in performance of soil. Better fragmentation, better performance, and better productivity. NCL identified its all kind of patches, identified patches, 5 patches, where we planned our blast design parameters and suggested for better fragmentation and PF. And this modification is generalized, but it depending upon modification can be done depending upon geology and hydrological condition of stress. Next slide. This is proposed blast design parameters. Basically, we have designed for all dragline patches or 20 cubic meter soil patches, HOE patches, and basically we have done HOE patches in our major contributor, and we have changes their drilling depth, and we have NCL and HOE patches both get benefited by this in a fragmentation point of view and productivity point of view. Next slide. This fragmentation analysis through WebFrag software we have done, and through mine distillation team we have done in 4 projects, and rest of the projects we have done randomly our various kinds of patches in NCL. Next slide. This slide you can see very clear picture. The 68 size, 50% of the fragmented material is crossing is less than 68 size. Quite good fragmentation. So this kind of fragmentation better for production. Next slide. This is the video how blast design in dragline and Khadia patches and how better fragmentation is done. This is a slide, a video only. Next slide. Next. This productivity of shovel via modification in loading operation, both side loading. This is the comparative analysis between single side loading and double side loading. Bench width required, definitely double side loading required 2 times of the single side loading. The single side loading is as per CMR, 3 times width of the dumper, largest flying plus 2 meter height of the pitch, whichever is the car. Cable bridging is not required in single side, but double side loading, essentially if electric rope shovel is loading cycle time, additional time for dumper positioning in single. Productivity overall improved in double side loading operation as it reduced the cycle time. Next slide. NCL identified some yes. Click this one. Here is how we are performing double side loading, and in this scenario we getting 60% increase. This is a patch. You can see one dumper is on waiting position and another is on load. Dumper positioning time is reduced in both side loading operation. So next slide. This is the improvement observed. It is observation. I'm not saying that this is only done from both side loading or anything. This is observation. Performance of 20 cubic meter shovel in financial year 23-24. Specific figure is 660 bank cubic meter per hour. Comparison to financial year 22-23, where bank cubic meter hour is 650. 8% increase here. Next slide. The productivity of shovel deployed in HOE patches. In April, this is April 2023. This figure is 3990 cubic meter per day by shovel deployed by HOE patches. Right now, it is 4333 cubic meter per day in November 20. This another measure has been done for improvement in productivity of dumpers. Third kind of measure we have started right now. 100 numbers of 100 ton dumper are planned to convert extended dump body dumper, out of which 75 has already been converted. Click please. This is a loading operation with extended dump body in Amblori project. Where that is a very much important thing, that we are getting more coal load without being use of any extra resources. The extended dump. And there is a comparative analysis. You can see first thing, coal loading at a time is 55 ton, and extended term body it can be go up to 75 ton. Absolute growth 20 ton. Loading cycle is 2.5 minute, and in extended body is 3 minute, 30-second more. Time per trip also 30-second more. Trip per day also one less per day, but total coal transportation per day per dumper is 780 tonni at each. That is quite remarkable. And here, assuming with 20-minute transportation time for a dumper, and average lead is 3.5 kilometers.
Complete the topic, sir.
Sir, my main topic has been already covered. This I am summing up all the other. Introduction of mine distillation. We have 4 projects taken under CIL mine distillation program, and 17 various use cases. Next slide. Next slide, please. Total 17 use cases is helping to perform better and monitoring of their performance. These are the cases, and this has been discussed previous papers. Very fast. This first mile connectivity projects. Ministry of Coal introduced FMC project strengthening India's energy security, reducing the reliance on imported coal. FMC will certainly boost our speedy coal evacuation in eco-friendly way. That's indirectly it will boost our product. Next slide. FMC. This is the status of FMC in NCL. The project has already been completed, and in this financial year, rest of also.
This conclude, Pandit.
Sir, other measures has been taken. Extension of dispatch through interquarterly transfers, development of CC road. This has already been developed by already discussed by sir. And next slide. Developments of Eco Park. Eco Park definitely improve our human value index, and it reflects in productivity also. It improves human productivity. Next slide is that this is site speaks of some eco parks. Next. This is the improvement observed in OMS. NCL has jumped up to the 37.50 ton per man shift till October 23. Comparison to last year, 30.71 till 22%. Next slide. This is graphical view of. Next slide. Yeah, as our vision, by attaining environmentally, socially sustainable growth, higher productivity with economic health is essential for sustainable. NCL is really committed for higher productivity milestone, hence achieving sustainable growth and vision of. Thank you.
Thank you. Question from the audience, please. Okay, Pandit. Thank you.
Thank you.
Thank you, sir. Now I request convener of the session to kindly give a gist about this session.
Presentation. No more
Have
stuff 6.
yes. So I call upon the chairman and the co-chairman and the rapporteur sir to felicitate our 3 authors. Sir. So I request the chairman of the session, Sri Professor S.S. Rai sir, to kindly felicitate our first author, Mr. Dinkar Tiwari, for the wonderful session on augmenting overburden removal of 20 cm shovels. A big round of applause to Dinkar Tiwari. Now I request the co-chairman, Vinod Kumar Singh sir, Area GM, Vichwa, to kindly felicitate Mr. Nachiket V. Bagari sir for the wonderful presentation on mechanical rock excavators and the technical feasibility of hard abrasive rock mass. Now I request the rapporteur session, Indrajit Singh sir, Area GMBM, Tina. Now I request the rapporteur sir, kindly felicitate Mr. Ajay Kumar Singh for the wonderful session on measures to improve the productivity at NCL project. A good round of applause to Mr. Ajay Kumar Pandey for the wonderful presentation on the NCL productivity improvements. Thank you, authors. You may kindly take your leave. We will continue the session with the second three set of authors, and so I call upon Mr. Shashiranjan sir from Chief Manager NCL Kadia. He shall present his paper on innovation-based maintenance, case study of 3372 Somnath, biggest dragline of Coal India Limited. Our next speaker shall be Mr. Rishi Srivastav from Sasan Coal Power Plant. And I kindly request the last speaker, Mr. Anil Kumar PS, to kindly come on to the dais. We have the next two speakers continue. I request Chairman sir to continue the session.
Present topic is innovation-based maintenance, case study of Somnath Dragline. I will request Sir Sasi Ranjan to present it.
Good afternoon, sir. First of all, I thank for giving me the opportunity to present my paper, sir. One more thing, sir. This is totally practical papers. Nothing academics, nothing line diagram, no graph, nothing like that. What we have done, I would like to present the same over here. I will start with a simple question of the audience. Is anyone of here ever wants to hear the three dreaded words, you have cancer? If someone says you have cancer, what is the answer? I think it is no. No one wants to hear that he is having such a dreaded disease. Likewise, sir, for maintenance engineer, for dragline people, if someone says there is a failure, there is no spares are not available in India, and even not it is repairable. It is just like a cancer for the machine. That too for a biggest dragline of this Coal India Limited. What we felt, what we just had this thing, they had experience of in the same thing in the Somnath dragline. So I would like to present these things. First of all, thank you to my general manager, sir. Gave me the opportunity to change the diagram just because of there was a production pressure. Headquarter team, Ramaswamy Saab is there, who gave us the opportunity, and he believed in us that yes, you can do it. So it was a change of design from OEM. It was against the OEM. So thankful to my respected GM sir and headquarter team. My co-author is Mr. Pramod Kumar Singh, who is in the Somnath dragline also. And I will straightforward jump to my paper actually, because this bell is a very scary type of. So many this thing has been told about this dragline. That dragline is Makka for production. That's what we have started with coal exposure in northern coalfields. Northern coalfields totally depends on this dragline only, 24 by 7 and 365 days. There is no holiday, there is nothing like that. Every time there is a, for this reason, there are some maintenance technique also. Rai Saab study told us, Professor Rai Saab, this condition based maintenance, calendar based maintenance and everything. We are just introducing innovative type maintenance. When there is nothing like that, we should go for innovation. When there is dark everywhere, we should go for innovation. So this practical thing, I am going to just present my paper, what was the problem and how we tackled it. This is a project review of our overview of our Khadia. We have 3 drag lines for the exposure of Turra seam in east and west of Khadia block. It's a geological cross section of Khadia project. OB removal is done by above the Turra seam is only by drag line only. These think the principles of drag line what we have, what we are hearing just up till now. Certain advantage is there that it can excavate at greater and greater depth. Some drag line issues. Drag lines designs require emphasis. This last line. For drag line designs require emphasis placed on developing components with high level of reliability and predictability, so that repair and replacement of components can be scheduled at time with less effect mining operations. These drag lines are totally field based. No workshop, all workshop and this thing has to be done there only at the field itself. So it is a typical type of thing that all workshop and all helping this thing, all equipment that needs to be for maintenance, that has to be done there only. So it's a typical and it needs extra care. So various factors, reliability and this improvement. The 7th point is maintenance, reliability, condition based maintenance and innovative based maintenance. The 33 by 72 of drag line. It was commissioned. It was commissioned in we have 2 for 20 by 90 drag line, Varanasi and Vishnu. So one more thing, the hourly loss. This is the figure of IED. The hourly downtime cost of drag line. Our Khadia project is like 803 rupees. Loss. And for 20 by 90 it is 1.3 lakh. The problem faced in Somnath drag line, problem which was faced that what we have seen that swing pedal figure which is showing the swing foot pedal, there is an encoder inside it. There is an encoder inside it and there is a hand joystick. So encoder which was inside this swing pedal, there was a failure of encoder inside the swing pedal. This encoder was not available in India. We looked out for many parties which were looking for this, which were in the job, but they are denied that is not impossible. It is impossible. This is of Germany make, and the procurement action would have taken more than 3 months. More than 3 months. So this pedal, this swing foot pedal, which was there, this is for swinging action of the this drag line, and hand joystick. There was a drag and hoist system. Drag system that side, and this time hoist. So this the total power was shifted to hand joystick of this thing. Next slide. Encoder is a device that converts mechanical motion of foot pedal into electrical signal for processing in swinging action of the drag line. The most important was it was imported. It was from Germany, and we cannot get it. It was not possible to get before 3 months. It was told us. So the fail rate. Our innovation team, since there was no way out, with discussions with our headquarters, our area general managers, It was a Herculean task because there was a change of design of OEM that needs special approval. So, lot of confidence from my higher ups, my seniors, even up to director levels also, was needed. So that things were done, and the belief that we can do it. There was a strong belief in our team that we can do it. So all things were done, and the machine was commissioned within a very short period. I think in a 3 to 4 days. This is the flow chart of all the circuit. Swing pedal encoder circuit was provided in hand joystick. The current reference level was 10 volt only, which was needed was 10 volt only, but actually there was 2 volt. This CPU was programmed. There was no enough knowledge and neither OEM support. So CPU was programmed like that. So CPU was programmed do the jobs in the 10 volts. That was a big job that was done. This is the activity chart which was carried out in nutshell. Then this was done in 3 days actually, and the new encoder was procured after 3 months. That I'd like to ask Ramaswamy sir how it was procured is a different story actually. Or it was an unstinted effort of headquarter. Even after 3 months that was procured, that was a big issue, and things were changed. This was the technical part, but the next issues was in operation side, how to do the operation, because our operators they know leg motion and hand motion in synchronization, but when we are just disabling the leg motions, it was very difficult for them to just do the operations by hands only. This hand habit of operators takes time, since it was operated initially. It was operated with reduced reference and only in daytime. Only in daytime, in broad daylight up to 6 p.m. It was told, and it will be idle. It will be kept idle for the night shift. Or special operation and care was also provided during the initial operation. There was a problems in operator also that it is not possible, sir, nahi hoga, ye hoga, but we anyhow manage. और एक्चुअली जब हाथ पैर और एक चीज छोटा सा चीज है, पैर और जब हाथ दोनों का मोशन रहता है तो वो लोग जागे, मतलब वो लोग का सब चीज इन सेंसेस रहता है, तो बोले लेग मेरा जब रिड्यूस हो गया है तो हम शायद नहीं कर पाएंगे या फिर तो इसके लिए बहुत सारा हम लोगों को उसके लिए उनको डेवलप कराना पड़ा, उनके इसको काफी इसमें हम लोगों का एफर्ट लगा, मेहनत लगा, रात भर उनसे बात होती थी, ऐसे करो वैसे करो करके, तो अल्टीमेटली इट वाज डन. इट वाज अ बिग स्टोरी वाज डन एंड थिंग्स वर सेटल्ड आफ्टर 3 months. Sir, one more thing, just because it was need, so some innovations were made. Now, maintenance planning in our day-to-day this workings of Madhya project also. And we are planning to just like quality WCL also, and we are planning. There is a regular problem or the problems which don't have any solution, literally catastrophic failure, no solution is. Well, we should go for the dedicated team which can do some innovation, and anyhow we can commission them. The innovation based is basically unpredictable breakdowns which we come across, and for sudden breakdown of the equipment is the best. I think when there is no way, we should go for innovation based. This was also awarded with 022. Coal India Limited. So, this is my totally practical paper what we have done, and nothing like that. It was many hit and trials were done. Many when sometimes we were thinking that no, we are going to fail. Next time sudden spark ups, नहीं यार हो जाएगा कर, नहीं यार हो जाएगा कर. So ultimately it was done and it was awarded with NMR. Thank you. This is my presentation.
Thank you,
It is
thank you.
totally practical.
इतने अच्छे काम के लिए इस हॉल से गुजारिश है, एक ताली तो बनती है खड़िया के नाम पे.
Mr. Pramod Kumar Singh, he was also the pioneer for this achievement. So I would like to just a few claps for him also.
Thank you. Any questions? I think there is no any question. Practical. Present paper is technical control in coal is damaged, lost due to cast blasting in dragline highway. Presented by Mr. Anil Kumar. I request you to present.
A very good afternoon to respected dignitaries and my dear beloved chief guests and to the delegates who are visited here. I am Sasanpuri Bhargav, manager from Sasan Coal Mines. I would like to thank ICOMS team for conducting a wonderful opportunity for sharing the knowledge and for exchanging the best practices. So today we are going to discuss about the technical control in coal edge damage loss due to cast blasting in dragline highway. This paper generally focus on the case study basis which is happened in Sashan coal mine. So the coal edge damage losses are occurring due to the cast blasting while for doing the dragline working. So to address this coal edge losses, we have created technical controls for coal loss and minimize this coal loss and to improve the recovery optimization. So further going to the details in this particular topic, I want to give a gist about our Sashan coal mine. So this coal mine is located in southwestern part of Moher substation, sub-basin, and these are having two coal seams. The top seam is of Kureva and the bottom seam is Dura. And the strike and dip direction is trending towards north-south and towards eastern direction. Next slide. This is the geomining characteristics and method of working. So here the cross section it is representing the top OB is going to be handled with shovel dumper. The coal is by FEL and loader, and the interburden which is going to be handled with a drag line. So the total capacity of this mine is 20 million ton, and the OB removal of capacity is per annum 78 MBCM, out of which 24 MBCM is going to handle with drag line. So the next slide please. So nowadays we are facing a challenges to manage the deep-seated opencast mines and to handle the substantial thickness of OB. So for this increase in coal extraction complexity, and there is a cost incurrence, and also there is a major impact on environment. Instead of keeping shovel dumper as a digging excavation, we can replace that shovel dumper with dragline for interburden, which is the cheapest method of transportation. For this, for this dragline working, we used to extract the cast blasting as a means of blasting, which is a very cost saving method. So after deploying this cast blasting, the reduction in height and the efficient excavation will be going to created for the dragline working. So this is the cost saving method, and this part of material of the desired volume is going to be casted into directly into the decoaled area. Next please. So how we are implementing this cast blasting in in Sashan coal mine? So we are having the large blast hole diameter of 311 mm, and the charge column is filled with ANFO and doped SME. So there are the technical targets and factors which we need to attain. That is effective casting percentage we need it for this such a big size of a drag line. and the targeted muck pile formation, like the vertical drop of 12 to 15 meter and lateral throw of 40 to 50 meter we required. Based on all the geological parameters and the explosive and blasting characteristics, we achieve the casting percentage of 28 to 33%, which will be in the range. So the yellow hatch part is casting material, which is untouched part by the dragline. Next. So I want to give a brief about the dragline cut parameters and the dragline specification. And the dragline specification, if I say that this is the one of the biggest dragline of 62 by 100, and the material handling volume per annum is 24 MBCM. Per day it is 35,000 cubic meter per day of each dragline. So the mine configuration, if you see that figure, the total strike length we are having is 4.7 kilometer approximately. The north pit we are having is of 1.4 kilometer, and the south pit which we are having 3.3 kilometer. The coal demand in our mines is 55,000 ton per day, out of which 27,500 is for Tura, that is the bottommost seam, which need to be exposed by the dragline by using the extended bench method, and the exposure rate should be 10 meter per day, so that we can achieve the rate, the exposure, the demand for power plant, that is Sashan power plant. Next slide. These are the technical parameters of it's a 3D view which are showing that the dragline positioning and the cast profile and the dragline bench height. This is the 77 cut meter width we are going to be taken, and maximum size we are going to be used for blasting is 3 to 50 meter, and for this we are using the staggered pattern. Next slide. And this dragline blast we are using with a low PF, that is 1.4 to 1.65, and the casting we are achieving whatever the desired we want, that is 28 to 33%. The overall impact in stripping ratio as well as the material handling volume, the reduction in material volume handling. Next slide. So now coming into the challenges which we are facing in the cast blasting in dragline working. So this is the image which I am showing. This is one of our cut which we have taken as a sample while we are addressing this issue. The cut width of 77 meter. Beyond that cut width, the coal has dragged and into the decolled area. It is of around 10 meters. It is going to be shifting. So this is the cross sectional view which I am showing here. There is a thickness reduction in the coal edge of 4 to 5 meter, and it is dragging into the decolled area, which is creating a huge loss for us in terms of additional handling of OB material. So, and also there is a challenge for the operator to assess the coal edge and also to predict whether the no coal slope is in a safe mode or not, because for every block where the coal edge is varying and the position of the coal edge is also shifting. So it is very difficult to manage the operator whether to take towards low wall side. It is required for additional cutting or not. Next slide. So this is one more picture which we faced during this cast blast. So while exposing this coal, we have got an additional amount of coal which is under beneath the casted material. So if I can say, the total loss which we are getting in this in our Sashan mine for dragline cut is of 4 to 5% is for only the rib pillar. This is the process. Is 4 to 5% is residual rib pillar, and the additional percentage which you are getting, that is of 3 to 4% of due to the spin into decolled area. This is a major concern for us, and is also creating a difficulty for assessing the coal edge, and as well as timely exposure, and the low exposure rate is also a major concern for us. Next slide. So during this, while this issue is these losses are incurred, the pattern which we are followed here is the total 6 rows we are having is from A to F, and this is going to be subgrade drilling up into the coal roof up to 4 meters, and which is going to be backfilled 2 to 3 meters, and the 1 meter is the positive subgrade which we are following in the past trend. So by this trend we are getting a negative results, which is of 3 to 4% of additional losses we are incurring in. Next slide. So this is the coal edge damage pattern which we assessed. So because we have taken a sample patch of 350 meter of size and we have blasted in the past practices how we are done to analyze how the damage is going to be happen. So after blast and after the dragline is exposed, we have seen the image damage pattern. Next slide. This is the damage pattern which we have observed here. The low wall side, the high impact zone, that is of 3 rows, that is EEF rows, is creating a major impact on coal edge damage. And the moderate impact zone which you are seeing here, by virtually we have gotten this result, and there is a minimum impact on that. And towards high wall side, there is no impact on it. So to mitigate these strategies, subgrade drilling and base charging are crucial for us to fragment the shale and interface zone. Next slide. So to eliminate this coal edge loss, so there are few technical controls we need to be adopted very precisely. Like we need to be taken the previous cut data, that is previous. This is the cut data which we are going to be accumulated through survey. So the green it is representing the floor of these particular cuts, and the red is representing the roof of the particular cuts. And always we need to be very careful about the creating the coal roof by using the previous cut and as well as the current cut, the pre-split hole data also, which is helpful for to make us more precise to creating the roof mapping. Next slide. So this is the data collection analysis we have done for total 500 meter patch. How the impact is getting and what is the amount of losses for every 20 meter block, how the damage is getting impacted on every 20 meter block. So the same pattern which I explained earlier, the 4 meter subgrade drilling we are doing for entire all the 6 rows, and it is backfilled with 3 meter it is backfilled by the drill cuttings, and 1 meter is the positive subgrade effectively which is getting. Next slide.
Please sum up.
Yeah. So this is the result which we have got, that is 3.4% we are getting loss in the entire 500 meter patch. That is, next slide. So after this loss, we have created, given a thought process, and we implemented a negative subgrade drilling in the low wall side, that is EEF block, EF rows. So we have done a negative subgrade drilling, so that we created a positive impact on our results, and it is reduced by 2% of damage. But still, it is a reduction, but there is no zero impact, but it is a reduction we have got in this practical result. That is the image which I am showing here after the negative subgrade drilling, how the coal edge is not damaged, the minimum impact. Next slide. So the comparison is earlier 3.41% and now it is 1.45%. Next slide. So due to this, next slide please. This is if the first image is showing that if the coal edge is not damaged, so then how my peak balancing diagram is going to be happen. If the coal is damaged, to recover that damaged coal, that is which is dragged into decoaled area, so I need to handle a 2,500 to 5,000 cubic meter per 20 meter block. So it is a huge additional loss for us, and in terms of exposure rate, in terms of productivity wise. Next. So to sum up all this, because our Sashan power is producing a power at a rate of 1.19 paisa, and this power production is very low rate. Our management has a main focus on to reduce the coal loss and also to maximize the coal recovery. So to make a balance between, so we have adopted this negative subgrade drilling. Next slide. Finally, we have achieved that the cut progress rate, that is exposure rate, by 0.5 to 0.7 meter per day we have exposed better after this coal negative subgrade drilling. Thank you.
I have a question. Told that you charge at very low pH 1.4 and 130 meter. I think it must be more than 10 rows. How much is your charge per delay and how much is your maximum charge?
Sir, this is somewhat confidential. I will share with you if you want to ask that.
Because we also face the same challenge.
Yeah.
And
Sir,
I want to tell that once the evening inquiry came from everywhere that is there any earthquake. Later it was found that there was a big blast in Shasam.
So we are not changed any charge per delay, but we have reduced the drill depth. The bottom charge we have reduced up to 1 meter. That is above the coal roof. We have backfilled with the drill cuttings up to 1 meter.
I want to say that there must be some relation between charge per delay and vibration. Vibration must be a prime concern because like us, you are also working in the same area. Thank you.
Just to take advantage, minor modification we achieved. Yes. Can you explain me? The modification was in the first 3 row.
Yes, sir.
Is
Yes,
that
sir.
correct?
Yes.
And that too also you just changed the subgrade drilling.
Yes, sir.
You reduced or increased?
Sir, subgrade drilling is
The same.
same. That is
Only you filled the material.
Fill the material
instead of exposing.
Yes, sir.
So, and that resulted in a full loss
Full
from
loss.
3.7
1.4.
And also, like for the audience question,
Yeah.
Thank you. Thank you, Mr. N. The next paper is also from Sas Power Limited. Sir Rishi Srivastava will deliver a case study. Optimization of dragline operation planning and sequencing for productivity enhancement.
Good afternoon to all the delegates present here from mining fraternity and other professional backgrounds. My name is Vivek Deka. I am a manager in Sashan Mines. It gives me an immense pleasure to discuss something on optimizing the dragline cut sequence. So let me please give you the contents of the presentation. We'll first introduce about the Sashan coal mine, but since my colleague has already mentioned, so I won't brag this much. Next, we are going to talk about the extended bench method that we are implementing in our Reliance Sashan. Why we need that extended bench method and what are the advantages and disadvantages of it. Next, we are going to talk about the objectives of the dragline operation, its processes, and what are the stakeholders in the operation team and other parties who are involved in it. Then we are talking about operational difficulties, what we face at site. Then we are going to talk about some different dragline positions based on its boom angle and the high wall. Then different cycle times followed by the cut sequences that we have formulated. And finally, we will talk about the advantages and disadvantages of the cut sequences that we will describe. We'll skip this slide as already my colleague has already explained about our mine. Next slide. So I would like to focus on the different dragline digging methodologies, like working in tandem, which is mostly common in Singrauli coal fields. And out here in our Sashan coal mine, we are using extended bench method. Generally, our cut width happens to be of 77 meter, and the block length we take around 20 meters. So in order to suffice the coal requirements, we have utilized this extended bench method for better productivity. Now, what is an objective of our dragline operation? Since this is a very robust machine, it should be confined and it should be time efficient, cost effective, and quality should be ensured in the quite efficient manner. So there are a lot of support functions that are working with this planning and operation of a drag line. There are operational teams, water management teams, electrical teams, human resources, operators, maintenance teams need to ensure those are availability, drill and blast teams, and obviously for communication, the IT. This entire things are managed and monitored properly by the planning team. Quality has been ensured, safety and risk management has been taken into consideration, and the management delegates this entire work to the dragline team. What they does is they develop a planning strategy, review and optimize all the work plans, monitor the compliances, and again reiterates if anything new needs to be implemented. Then the final execution comes with proper safety. Next. What are the operational difficulties? I know of us will be aware of it, but I just wanted to provide a glimpse. There are a lot of parallel activities associated with draglines, such as dosing, grading, marging. So the percentages of dosing, grading, cable handling should be in a reduced level so that the productive hours of dragline is at the optimum level. Nextly, due to its large dimensions, maneuvering and repositioning the dragline is a hurdle always. Then comes the rig repairs and spare parts availability. Due to various cut phases, dragline gets exposed to sometimes bad high wall, resulting in the damage to the rig parts. Availability of the spare parts and maintenance also becomes one of the major issues. Then through balancing diagram, proper volumes of dump and dig, excavation and different positions need to be focused on, followed by what is our coal requirement. We need to keep focus on that also before planning the cut sequences, followed by water management, since the rig parts gets damaged a lot when it gets excavated, the bucket gets excavated and gets exposed to water. Finally, we need to focus on drill and blast team also, since we need a proper safe location in order to reposition the dragline during blasting. So as I told earlier, there are three cut sequences, and before that I need to explain the cut profiles of the dragline along with in alignment with the boom length, the high wall. If the dragline's boom is parallel to the high wall, then we can put as online position. If perpendicular square, and if it makes an acute angle, then we can conclude as offline. So the case study that we have considered is a 300-meter patch length. Out there, we decided that three cut sequences can be formulated. We had considered different factors such as dosing, grading, meshing availability, different cycles, proper interaction with the operators, and then we concluded about those three sequences. Next. What are those three sequences? First, let us consider this 160-meter patch to be a 351. Because of the shortage of the slide, I just started with the 160 meter. In that 300-meter patch length, suppose this key 1, B1, NC1, K represents the key cut of extended bench method, B represents the box cut, and NC represents the no. This 77-meter width, and the circles that I have drawn with green symbolizes the dragline's position as numbering 1, 2, and so on. In order to excavate the K1 key cut, the dragline will reposition itself at 1. It might be square, offline or online. We need to decide on site based on certain parameters. Simultaneously, it will move back and excavate all the 5 key cuts. Then it will move towards the box cut. It will excavate 3 or 4, and then it will move to the no-go. So making a diagonal sequence pattern. Out here, when the 300-meter length was completed, the propelling distance came to around 2800 to 2900 meters. The next cut sequence is similar to the diagonal, but out here it will complete the entire key cut followed by the box cut and then the no pole, making a W-shaped pattern. The propelling distance came a bit higher as compared to diagonal. It's around 3050 to 3150 meters. And the last one is the Z cut pattern, where we will square it off. Key cut, box cut, and no coal will square it off and expose it to the coal winning team for immediate excavation. But out here, the marching distance came 3,800 to 3,900 meter is substantially high as compared to the diagonal sequence method. Now I want to inform that we are undergoing with this diagonal cut sequence methods 90 to 95% of the time with our dragline operations. So let us discuss regarding the advantages of this method. As I have mentioned earlier, in order to have a safe distance for during blasting, it can be easily planned with this method. Then advanced dosing activity is possible. When the dragline boom length is away from the doser, it can go and dose the patches for the next cut sequence, next cut excavation. And parallel activities of coal winning and dragline working are not hindered as the is away from the dosing area. We haven't found so many difficulties with this method, but suppose we require the coal at a very nascent stage immediately, then we cannot provide the coal for coal winning team with this method. However, in the other two methods, the marching rate is quite higher, hindering the productivity of our dragline. And here we can see if more marching rate is there, it increases the unproductive HMR, resulting in the increase of unproductivity basically. So extended operational hours also contribute to increase in machine depreciation in both the W cut sequence and Z cut sequence. And more cable handling time is also required. So I do not want to stretch this further. I just want to conclude in the other way that out of all the three options that we have formulated, this diagonal method happened to be the most optimal one, as the other two took a lot of marching time. The diagonal method not only manages the marching rate but facilitates the other activities, that thus reducing the dosing percentages and the subsequent cut or digging. If the dragline exposure rate is aligned with the coal demand, this method is the most optimum one, as it's most flexible in its operation. Thank you.
Thank you. Any question from the delegate side?
If none, then I have one question. Said that save a lot of marching time, dragline, actually converted. And we discussed three scenarios. One is the diagonal. The diagonal cut. Key cut is 2 dig block advance. The dig block. Just trying to figure out.
So we have done for a lot of incidents, and we found out that 5 cuts at one go will go for 5 key cuts, 100 meter patch.
So it means 100 meter you 5 dig block length.
Yes.
5 dig block, and then you do the box cut, and then do the. And in the scenario where you went for the square, this yielded the maximum unproductive. Yes. The middle one was what? Axial.
Completely expect the key cut, then coming for the box cut.
All the full blasted material you expect the key cut and then box. I think NCL can take note of it. This has given a very good insight. The line production digging sequence is very important. It's not like the showers. In this case, there were 6 digging sequence. How did they manage this 6 digging sequence? That yielded very good results. Thank you.
So what is the block length you took for this dragline sequencing? 20 meter in, it seems to be very less.
No. Please don't get confused. There are 2 terms used in international operations. You are asking the bench width, that's a separate bench width.
No, I am asking about the block, that means length of the cut in one sitting. That's what I am asking.
Dig block length in one dig block length.
Yes, one
the dragline is going to take 6 positions.
Okay, but what is the meter that is taking in one cut operation?
No, because one dragline operation is the complete digging sequence, which is a 6-year. Because that's also an optimization. Dig block length is also very important. Take 2 long dig block length.
then there will be too much of marching.
Yeah,
Okay?
block length seems to be less, 20 meter. For this kind of very big drag line,
That you
block
need
length
to
is too
arrive
much.
scientifically. There are ways and means you can optimize the dig block length. Shorter the dig block length, it will also yield to the more marching. Longer the dig block length, it will also yield to the more marching.
Yeah, that's yes.
So
And
we need to optimize.
actually, this seems to be advantageous when only there is no immediate coal requirement.
Exactly, sir.
But you have to wait for coal to expose. So that
Sometimes,
disadvantage is there in this method.
sometimes what happens is if you're moving into the cut end and the immediate coal requirement is required, not have support, not have any storage, then we need to for the red cut sequence. Although happens to be in the higher side of marching. So in that time, we need to compromise with our productivity in order to provide the
Yeah. This when there is immediate coal requirement is now that we can use this method.
90 to 95% of the time we keep with diagonal sequence itself unless requirement is very good.
Thank you. Now I request Chairman Sir, the session, Professor Rai to conclude the complete session.
It's pretty difficult task. Still, let me try. Get few from each of them. So the first question, Malik Sahab. So I started with by Malik Sahab, and he says that India needs coal. Also given such commitment. Followed by the Dinkar, worked on some carried out of 190 and like shut that which is going to affect. Second presentation from the replacing or splitting various blocks. One of the options was the rock excavation, pyrotechnic. But one question still remains. All these techniques maybe may work small 500. Can any excavation machine build this? That's this. And compared all Kotse Sahab can approach begin with based on the attitude that has later on by different measures that has taken like making of sequence, digitization of many first mile. Shashi Rai, when I was one word was coming, very popular. This is a wonderful start that we applied our knowledge, bypass some plastics, develop a skill. Right? Nothing a driving is better first nice start rather than buying the knowledge. Solve the problem. Then coming Reliance to quite time it get try to reduce the losses
quite a bit, not a great quantification. Likewise, managing for me, I have significant backline. Naturally, you are, I think, all this sharing practical that's encouraged.
Thank you, sir. Thank you, everyone, for your attentive participation in today's technical presentation on operational benchmarking in Opencast Mind. We have had privilege of hearing from our distinguished speakers. Now it's time to let's express our sincere gratitude once again to the speaker of the commendable effort in presenting their enlightening session. Have a huge round of applause for our distinguished speaker. Ladies and gentlemen, please. Just remember, operational benchmarking isn't just a concept. Rather, it's a catalyst for transformation in our industry. I now request Chairman, Co-Chairman and the Rapporteur of the session to please come forward for the felicitation ceremony. I now request the Chairman of the session, Professor S.S. Rai to kindly felicitate the author of the session with memento, Sri Sasi Ranjan Sir, Chief Manager, NCL Khadia Area. I now request Co-Chairman Sri Vinod Kumar Singh Sir to kindly felicitate the author Sri Vivek Deka Sir for the session with a memento. Ladies and gentlemen, please put your hand together for this felicitation ceremony. Again, I request the rapporteur of the session, Sri Indrajit Singh Sir, to kindly felicitate the author, Sri Shashanpuri Bhargava Sir, Manager Sasan Coal Mines. Have a huge round of applause for Sasanpuri Bhargava Sir. Now, I request the convener of ICOMS 2023, Chairman Sri S.S. Rai Sir, to kindly felicitate the co-chairman of the session with the memento. Please put your hands together for Vinod Kumar Singh Sir, AGM Dudi Chua. I again request Sri S.S. Rai Sir to kindly felicitate the rapporteur of the session, Sri Indrajit Singh Sir, AGM Veena. Have a huge round of applause for AGM Veena, Sri Indrajit Singh Sir.
Thank you, sir. So, we shall conclude this session here. We shall break for the lunch till the next exhibitor session at 2 p.m. in this very hall. All delegates nominated from the NCL areas and units, CIL subsidiaries, exhibitors, organizers are mandatorily requested to kindly make yourself available in this hall for the exhibitor session and followed immediately by the valedictory session. So it is mandatorily requested for all the nominated dignitaries from the NCL areas, units, CL subsidiaries, etc. Because CMD sir shall attend the same meeting.